going to discuss about what exactly should the course curriculum, what we are going to cover inside the whole course of Big Data and Hadoop. So this all consists of 10 modules. The module 1 starts with understanding of Big Data and Hadoop. The second module will be Hadoop architecture and HDFS, where the word HDFS stands for Hadoop Distributed File System. The third module consists of the Hadoop MapReduce framework. Next will be advanced MapReduce concepts. Then we are going to followed by Apache Pig, Apache Hive, Apache Hive advanced part, and HBase the basic introductory part. Module 8 will consist the advanced part of HBase. HBase is basically a NoSQL database. It is basically a cookie value based database. I'm going to discuss in detail. It is quite important for you. Then we are going to have a new concept of Apache Spark, how we're going to do the analysis using a Scala and all. And at the end, we have to wind up this with Apache Uzi. Each and every module having their projects, each and every module have their POCs, they have your assignment, they have your whole learning curve that I have to discuss. So we are going to focus in such a way, the module is such a design in such a way, having 30 to 40% part will cover the theoretical or conceptual part, remaining each and everything will be having the hands-on and the project-based module. So this is a course outline for the whole course. So before moving the whole thing, why we are going to learn big data, what the career scope for that. So this is the trend for you in front of you. So this is the prediction made by McKinsey and CAGR. They told like this in coming 2022, the market of big data is going to increase rapidly, because there are so many requirement of data analysts and data experts over there. The big data Hadoop market is undergoing gigantic evolution and is showing no sign of declaration. Big data and Hadoop skills could be the transformation between your current career and your career. You can see a dream career. You'll just take a leap from your whatever you are doing in terms of developer, in terms of data warehousing. You can just take a leap and go and move forward for your dream career using the big data technology. So there are multiple reasons why you can go for big data courses and big data like technologies. First thing, like Hadoop is a gateway for big data technology. Okay. The second in Hadoop is a distributed disruptive technology these days. Various big data and Hadoop jobs file are across the globe. The second is like we can cater multiple professionals having the different backgrounds, be it a Java developer, be it SQL DBA guys, be it a software tester, be it anyone who is coming from data visualization or ETL profile. They all are welcome in this particular domain. Then the big data Hadoop is now is trending job. Okay, they have the highly paid job these days. Now these days there is scarcity of big data developer professionals in this, and in each and every company whosoever dealing with log processing, search engine analysis, they all are looking for big data developer for these days. So this is a great opportunity we have, how we have to go for big data technology and how we have to skill up. So the in big data ecosystem like things. So the trends is in front of you. This is the only reason why it's in demand in market like thing. So we have to go. Let's try to understand what exactly Hadoop is. So before this, I have to let you know Hadoop is not a tool. Hadoop is not a database. Hadoop is not a language. So in short, what we can say, Hadoop is basically a framework that allow you to first store the big data in a distributed environment so that you can process it parallelly. There are basically two components in Hadoop. First one will be termed as HDFS and the second will be termed as YARN. So what is HDFS is basically the Hadoop distributed file system that allow you to store data in various formats. So when I'm going to use the word format, it means data could be structured, data could be semi-structured, data could be unstructured. Okay, so this is completely what we have, and that has to be discussed in detail in the coming session over there. And finally, we have to do the parallelization. We have to speed up the process. For this, we have process engine that will termed as MapReduce. So how Hadoop evolved, that is from the research paper of Google that was published by Sanjay Gemawat. And the cutting implement the same concept in existing Apache Nuts project and try to evolve an open source platform, and that will termed as Hadoop. And the word Hadoop has been given by Doug Cutting as it was a toy name of his son. Okay, so there is nothing technical about that. So we are going to discuss about in detail what exactly Hadoop is, how we have a comparative analysis between Hadoop and other existing traditional systems. So the founder of Hadoop will be like Doug Cutting and Mike Farella. So we have to discuss that again in the coming classes in too detail. What exactly Hadoop is, what is the main feature of Hadoop. New term over here is what is big data. So anything could be big data. But the thing is that what is your reference? Means a data, let's say you have pen drive 16 GB and you have data of let's say 16.1 GB. But for this particular pen drive having a 16 GB of capacity, we can say that 16.1 GB is a big data. So what we are going to have a reference over there, the reference is volume. Okay, so having that term into consideration, we have the definition of big data. We can say this any data is termed as big data if it's going to satisfy five V's. So what are those five V's we have? Like volume, velocity, veracity, variety, and value. So we are going to discuss the same thing again in detail. What exactly the meaning of veracity, what the meaning of value, what is the meaning of velocity and variety. So we cannot say like this big data is in general term. We have to use a certain parameter to define the big data. In coming classes, in coming modules, we have to cover in detail why this big data technology is all about. So make it general, make it layman, you can say big data is the problem for IT industry. And to solving this problem, we have a solution. The solution is Apache Hadoop framework. So to solve it, to cater it, we have to go for big data and Hadoop course. First is, if we are dealing with big data technology, if you are the experts in big data, so you are quite well welcomed in the various domain and various sectors across the business line. They could be retail sector or consumer goods, that could be financial and fraud services, web and digital media content platform, health and life sciences based companies, telecommunication companies, e-commerce and customer services. So right now there are multiple companies, they have been implemented big data technologies in their ecosystem termed as Walmart, Bank of America, AT&T, and NextBio. So here I try to mention the different domains. Walmart is a retail chain, Bank of America is a fintech, AT&T is a telecom company, NextBio is a biomedical company we have. So be it any domain across the globe, they all are whosoever is dealing with data, they have to go for big data analysis. They're looking for the big data developers. So what are the purpose? What is the role of you? Let's say you have to do for you have to check a loyalty program. You have to run a campaign for the management of customers. In that case, in retail or consumer goods sector, definitely you need some data. You have so many inputs from different sources, and you have to manage and do the analysis. In that case, obviously you have to go for big data technologies. Same with fintech and fraud analysis. You have to do the risk analysis. You have to check the accounts. You have to do the fraud detection, security analysis, credit risk analysis, scoring. Okay, you have to do for trade surveillance. So in those particular activity, you need like the data and you need like the big data developers. Along with again, you have to go for big data in web and digital media content. You have to go for fraud analysis again, social graph analysis over there, campaign management and loyalty program. We have to go for big data technology. Along with this, we have healthcare and life sciences, where you have to go for disease pattern analysis. Over there, we have to go for clinical trial data analysis. We have to go for drug discovery and development analysis. In that case, we have to go for big data. In telecommunication company, when you have to do a CDR analysis, CDR stands for customer detail records, network failure, network optimization, mobile user location analysis, customer churn prevention analysis. In that case, in telecommunication companies are using big data. In that example is Ericsson is there, AT&T is there, we have Nokia, Siemens network are there in India. Okay, Airtel, Reliance, Jio, they all have been implemented big data technology for the various tasks along the globe. E-commerce company like Flipkart, Amazon, they all are using for this. They can you can based on the customer behavior, we can offer a particular discounts. Okay, right offer the right time. What will be the next big offer? When will be the next big billion day over there? Okay, so event analysis, each and everything can be done with the inputs what you're going to have with on our particular pages. So the good thing is you are belonging to any of the domain in the business sector. You all are welcome in the field of big data. Whatever the technology, whatever the customer or client requirement is, that can be met using big data and Hadoop. This is the last slide what we have. So over here, I'm just going to discuss what will be the course curriculum. In this course curriculum, we're starting with the data loading tool. So you have the on your screen at the bottom, Apache few scope. They are basically data loading tools. So you see that what we are going to do, we are going to dump the data. Data means data could be structured, semi-structured, unstructured into our file system. And here the file system we are going to use is HDFS. After getting the data from various sources, be it real-time sources like websites or batch or traditional sources like MySQL or MS Excel file, so we can dump the data into HDFS. After getting the data into HDFS, we have to process this data, and for processing data, we can use any of the languages. You can go for Python, you can go for Java, or you can use the primitive or the basic languages used in Hadoop ecosystem. For this, we have Apache Pig, we have Apache Hive. In terms of databases, we have HBase. For the whole cluster management system, we have Zookeeper, Ambari. We have data injection and streaming platform over here is Apache Kafka that I have to build for machine learning thing. We have to go for Apache Spark. And recommendation engine, we have to develop the recommendation engines in Apache Mahout. Then for scheduling the job, for scheduling each and everything, we have Apache Uzi. So this is the slide. This like is all about Hadoop ecosystem, we can say. And as I discussed on the second slide, what will be the course outline? This is exactly the course outline that has to be covered in the whole course. So in the coming classes, in coming series, we are going to discuss each and everything in detail. Thank you for your time. Great learning. Be in touch. Keep learning, boys. Thank you. So big data is a term for collection of set of large and complex data that has become difficult to process using in-hand database management tool or traditional data process application. So over here, I am highlighted three things over here. The word big data, large and complex. So what is the meaning of that? So before this, again we have data. We can't deny this. We are not dealing with data or big data, the new term. No, it was already existing market. But right now, what happening? The companies like Amazon, Microsoft, Samsung, YouTube, LinkedIn, Twitter, Flipkart, Vodafone, what they are doing, they all are generating data from different sources. The sources could be e-commerce platform, the sources could be smart devices, IoT like platform, cloud services we have like YouTube has video platform. Okay, so using such a platform, they are generating data in different formats. Okay, this format could be the structured data, the data could be in the same structured data and different type. So if we have everything, means the data volume is so large, so complex, so the traditional database system cannot handle it. So what is the meaning of traditional database system? It means the MySQL, you all know it. We have databases like Oracle we have. So they all are the traditional databases, or we can say RDBMS. They have to store data into row and column format. Make sense? So if this data right now we're dealing in is purely semi-structured or unstructured way, so how to manage this data, how to store this data, and how to process data, this is the challenge what we are facing right now. So dealing with this problem, or in simply we can say like this, the problem what we are facing right now, how to manage this big data, we need some solution. So rescue this, so giving the solution, we have another term or terminology we have. The terminology will be what we can say Hadoop. So what exactly Hadoop will be, how it going to process, this is we're going to discuss in coming classes. Right now, I have to define again what is the meaning of big data. So any data will be termed as big data if it is going to satisfy 5V. So what is the meaning of this 5V? The first V is volume, the second is variety, third is velocity, next is value, and finally veracity. So in general means volume means the data which are going to store or process has some volume. Means volume means how much amount. It could be 1 terabyte, it could be 1 GB, one could be petabyte to zettabyte. So it depends. So here we have to have a reference. Let's say you have a pen drive having a capacity of 8 GB and you're going to store data 1.1 GB over here. So that data will be termed as big data for that particular pen drive. Make sense? So in the very same fashion, if whatever the database system we are dealing in current scenario in our business use cases, so whatever the limit they have, let's say 1 petabyte, the data beyond 1 petabyte will be termed as big data in terms of volume for the scenario of data analysis. In the very same fashion, variety, the data which we are going to store and process, they have different type. Hence, they could be a text type like Word format, Notepad format. The data could be into Excel file, XML file like semi-structured data we have. The data could be into any audio file, image file, or something like the coding environment, XML file, .json file we have over there. It means right now, again, I'm discussing the same thing. If we have data have in different format, means so the data will again comes in a category of big data. Velocity means the rate of generation of data. at which rate we are going to generate data over here, that has to be discussed. Value means a data is there which have all three parameters like volume, variety and velocity. It is going to give a certain meaning on a specific topic, so that data gives a certain meaning on that particular use cases. So that data is again termed as big data. Variety in simple meaning is that authentication. Okay, so the data should be authenticate or should be approved by a certain industry, so for the particular use cases. So in simple words, what we can say for defining the word big data, a data will be termed as big data. It is going to satisfy these five V's. Make sense to everyone? Now moving further, we have a question over here. So the question over here is like, you have three sets of data. The first set of data is like XML data. We have email body, audio, video, images, and data from enterprise editions. Okay, makes sense. So what we have to do, we have to categorize this data depend upon the parameter of variety. So before moving further, what exactly variety means, let me rephrase the system. You have to categorize this data into three categories. Which one is comes in the category of structured data, second is semi-structured data, and the finally unstructured data. So over here, let give me the solution for that. And we are going to discuss it again and again. So over here we have data with XML format that we termed as semi-structured data. And the data in email body, audio, video, image files, that all will be termed as unstructured data. And finally we have data which is into row or column format, or we can say the data which are going to in ERP system, CRM system, that all will be termed as structured data. Does make sense? So in coming slides, in coming lectures, we have to focus detail about what exactly the meaning of semi-structured data, what is the meaning of unstructured data, and what is the meaning of structured data, that had to be discussed in coming classes. So till now over here, we are in a condition to understand what is the meaning of big data, or what is the definition of big data, and how this is going to be in real case use cases, how they have been implemented over here. Okay, thank you for till now. In coming classes, we're going to discuss in detail about the rest of the topics. Thank you all. Next session, here we're going to discuss about this, which are the company or organization they have been using big data and what are the purpose for that. So let's move further. So we have common big data scenario, customer use cases and all. So we have to focus on that, which are the industry. Let's say we have eBay, e-commerce platform, whereas they are going to use big data, and since they are using big data for the purpose of web and e-tailing, where we have to generate codes for recommendation engine. We have to focus on ad targeting based upon the customer behavior. We have to suggest the particular product to them. Okay, moving further, we have so many use cases in the banking sector, as well as we have the retail sector, like Sears is there. So step by step, we're going to focus on each and every section. We have to start it with e-commerce, then we are going to move further for the telecom domain. We have to do the customer data analysis or churn prevention like task over there. So there's again going to discuss over here. Then we have CDI analysis. Okay, so it is going to discuss about again the customer behavior, and depending upon the use cases, we can recommend product services to the particular client and whosoever is our user. So be it e-commerce, be it telecommunication company, either it could be any government official company, let's say Aadhaar in India, where we have to go for fraud analysis, biometric detection and everything. So in that case, we can use the data. And moving further in biomedical field or healthcare, life sciences, depending upon the data of any particular syndrome, or you can have the sequencing of any particular biotic genomes, we can channelize the whole data for the purpose of drug safety and all. So each and everything over here, whatever I'm mentioning, what are the use cases, how many companies have been used Hadoop or big data for their use cases, that will be mentioned over here in Google. So for this, just go on Google and type the keyword Hadoop powered by. So over here, just going to click on the very first link. It will going to list it down how many companies are there which has been implemented Hadoop for their business use cases, and accordingly we're going to let you know everything. So let the page load it. Before this, we have to discuss about our agenda. So till now we have covered the first part, what is big data and challenges. Then we have to move for how Apache Hadoop is going to deal with big data and how many companies they are going to use big data. So till now we have discussed a couple of use cases. Now we are going to discuss in detail. For this, I have to go to the page over here. Right now, we are here in the powered by page. So the company's name has been listed from A to Z. Over here, we have everything is there. Let's say how many companies are using Hadoop in which scenario right in front of us. The first company name is Amazon. So it's clearly mentioned that uh, Amazon is using Hadoop using the language termed as C++, Perl, and Python. Means in data science we have to deal with data and we have to process data. So processing data we need some language, and storing that particular data we need databases. So we are going to discuss both, like software part as well as the hardware part, along with what sort of tools, hardware, software, languages, or any API will be required. That we will discuss step by step. So here are the use cases. So how many companies we are using Hadoop again. So Amazon is there, and they are using for what purpose? The purpose is clearly in front of you. They are using for analytic, and for analysis purpose they are using Java and their respective APIs over here. I think it sounds clear. Now moving further, the second use case, we have Adobe over here. So Apache Adobe is using Hadoop for the purpose of social services. Okay, and they're using the whole system using the any cluster mode system. Over here we have 30 node cluster system. So here the word node means a simple computer. Means Hadoop is working in cluster mode. They are working in a distributed platform like that. So the whole new terms are there. There are so many new words that are going to be discussed with that. What is the meaning of node? What is the meaning of this HBase? We are going to discuss step by step. So till I'm just try to make you familiar. There are the companies over here. There are companies across the globe. They are using big data technology right now in front of you. Alibaba is there, e-commerce giant from China. So they are again using Hadoop for processing a large amount of data. Okay, and they're using for this they have 8 core subsystem. Okay, and they're using the RAM capacity of 16 gigs, and they're having the storage capacity of 1.4 terabit. Okay, accordingly we have so many use cases. So you can just refer this link over here. You can find out like there are numerous companies around the globe. They're using big data technologies, and depending upon this they're using their Hadoop ecosystem tools. It could be Apache Pig, it could be Apache HBase. Okay, so depending upon that we have to choose in which their particular platform we have to go for that. Apart of all this, we have many more too, like a Scala is there, we have Pig is there, we have HBase is there, we have Solar is there. So in a particular scenario over here, we are going to discuss each and every tool in coming classes, and that will be part of your project as well. So I think it gives you great sense. Like this is the whole evolving field where each and everything has been used in different use cases. So we're going to focus in detail for that. So let's back to our slides. So we have to focus on what are the limitation of existing databases we have. Means right now we are moving to big data from your traditional databases. So traditional databases means we are going to use right now RDBMS, or you can say Oracle databases for particular business use cases. So here we are going to discuss what are the limitations we are facing in terms of RDBMS, in terms of data analytics architecture, and how big data comes as a rescue for that system. So the main thing is that initially what we have to do, we have to collect a huge amount of data, and that data has to be stored in a certain database. In a green, or it's clearly mentioned, this is the storage unit. It has to store the whatever the data which are going to append from different sources. The sources could be any bank, financial company, any e-commerce company, or any social media website, or you can see anything you can think of that could going to handle data. So the data has to be appended in a particular database. Now, after storing each and every data, we have to process data, we have to fire query, we have to perform extract, transform, load, that is ETL grid, that task we have to perform per year, and then finally we have to do the business intelligence like thing. Okay, but the limitation what we are facing in traditional databases, RDBMS and MySQL, is that there's a limitation of storage. They have their limitation in terms of storage. They can store only 1 terabyte, 2 petabytes of data only. And if they're going to deal with more data than that, in that case, what will be going to happen is this: the data will be archived. Okay, so we are not going to have the great sense of output in that case. I think it makes sense. Now, how big data comes in a rescue for the very same thing is this. Now, Hadoop comes with a new concept over here. They have the store plus compute grid. So we have to focus in detail about this. What will be the meaning over there? So before discussing about this term, what is the meaning of store and process script, let me explain you first what exactly Hadoop is, what is the purpose of Hadoop, what is the definition of Hadoop, then we can explain this slide. So in coming classes, I am just going to discuss this slide along with the definition of big data along with Hadoop. Thank you. Hello. Hello. In terms of storage or in terms of file system, the file system which is used in Hadoop having a particular nature. The nature is distributed. Okay, so right now the file system we are using over here, file system, just consider file system as a database. Okay, so the file system what we are using to store data is static in nature, that will going to locally host it somewhere in your local machine or in a particular server, and they can't connect with so many computers at the same time. But Hadoop comes at the rescue for that. Hadoop say if you have data and in a particular instant of time, so the data could be shared to multiple resources or multiple system, or multiple system can access data on the very same time, means we are working in the fashion of parallel processing. So what is the meaning of distribution, why distribution is going to be ethical in the coming scenario, and how we are going to correlate this feature in coming classes. So I'm just going to give you a mathematical demonstration what is the benefit of distributed file system first. So over here we have a solution right now. The solution is what? Let's say you have a laptop or a file system, we can say having the capacity of 1 terabyte. Okay, so being over here, we have a system, have a hard disk which has a data capability of 1 terabyte. And my question is, you have to find out the time, how much time it will take to read the data on the go. Means, let's say you have a laptop. Okay, we have 4 input output channel, and each input in output channel has the speed of data read and write of 100 Mbps. So having that in calculation, you have to find how much time it will take to calculate the read or write speed over there. Okay, so this is the case. How much time it take for a single machine? Again, the same data is going to shared with 10 different machines. So how much time it will take? So we have to do the analysis, and it is going to give us a clear picture what is the exact difference in between the distributed in nature and static in nature. Okay, makes sense. So let's see how to make the calculation over there. So you have to calculate over here the time. So for calculation time, you have to divide everything. Means initially you have to mention go there and mention your data is 1 terabyte. So you have to convert this data into MB. So I'm just going to convert into MB. So it will be like 1024 into 1024 MB. If you're going to give the data into terabyte, it will equal to 1 terabyte data. And after this, we have 4 channels. As the question has said that we have 4 channels, and each channel has the speed of 100 Mbps. Okay, and now we need the data into minutes, so that's why I'm going to divide it by 60. I think this calculation is too simple. Okay, so using the calculation, I'm just going to have an answer over there. So to going to give me the output is 43 minutes. Means this whole sort of calculation gives me the output, and that output will say if I'm going to read the 1 terabyte of data using a machine or a single machine. In that case, we have the total time is 43 minutes we're going to have over here. But if the same data is going to share in between or among, we can say like this 10 machines, so how much time it will take? Just divide 43 by 10 machines, so it will going to give me the output is 4.3 minutes. So this is the utility why we are going to focus on the distributed file system environment, because we have to have only one criteria. We have to speed up the process speed. The data processing should be increased. So it will be done using when your data is going to share between the cluster of commodity hardware. So cluster means collection of nodes. And whenever I'm just going to use the word node, it simply means a computer or machine. I think DFS is clear. So having said this or having the concept over here, we are going to use our file system. So Hadoop says whenever you are going to use file system or where you have to store data, so the data is going to store in a particular file system FS, and this file system has a particular property, it is distributed in nature. That's come the word DFS, and this is the database or default file system at Hadoop, so that will be termed as Hadoop distributed file system. In simple or in short, we can say HDFS. So what is HDFS? SDFS is the file system or distributed file system in Hadoop that will going to store data by default. So this is the basic introductory part of the storage part of Hadoop. We are going to discuss again in detail because this is the introductory system. We are going into this, so we have to go to focus over here how to read data into SDFS, how to get or retrieve data from SDFS, what are the commands for that. We have to focus on that. Now, in coming classes, we have a comparative analysis in between RDBMS versus HDFS. We have to focus on what is the difference between HBase, and we have to focus on what is the difference between HDFS. So all sort of comparative analysis we have to go on there. So there could be different parameters. The parameter will be schema on read, schema on write, the latency factor. So whatever the factor you can think of for any particular database, that has to be covered in the coming classes. What is Hadoop? This is the main thing that we have been to discuss again. So till now, we are in a condition or we are in such a situation right now. We know there is a problem right now we are facing right now. This problem is basically a big data. And whenever I'm going to use the word big data, it means the data which has to satisfy 5 ways. I told you in my very first class over here, we have been discussing about the 5 parameter like volume, velocity, veracity, over there, value. Okay, so those term is basically going to specify a very specifically say that this is big data. So be in layman language that big data is a problem for this industry. So getting the rescue of that particular problem, we have a particular system. Okay, that system is Hadoop. Now I'm just going to make it very much clear what exactly big data, what exactly Hadoop is, or Hadoop is a framework, language, whatever it is. I'm just going to discuss right now. So over here, it is clearly mentioned you have to focus on two things: the words which are in blue, okay, or which has been bold over here. So what is Hadoop? Hadoop is basically a framework. I'm just going to repeat the word framework. It is not a tool. So Hadoop is basically a framework. That framework was developed by Apache. So Apache Hadoop is a framework that allows storage and processing of huge data sets across Hadoop cluster in a distributed and parallel fashion. Second, Hadoop cluster is highly scalable and use commodity hardware which are relatively cheaper. So what's the meaning of that? So basically, it is a framework that can perform two tasks over the big data. And then task will be storing data and processing data. And whenever I'm going to use processing data, so the process could be into two sections. The process could be sequentially and the process could be parallelly. So here we are following the parallel mechanism to speed up the process. Okay, the second core thing is this is an open source framework, means for using it you need not to go for any licensing like stuff, so it's totally free for you. You can go for that for your commercial use, for individual use, or any community use. So in that case, totally open source. You can just go on Apache website, you can download over there. I will let you know how to do it and how to configure it. Now the second good part is this: we need not to have any fancy hardware. You need not to spend so much money on our hardware, because we need not to go for any high terabyte or high petabyte of data like system over there. So whatever system you're using, having minimum 8 GB of RAM, 1 terabyte of hard disk, that will be going to work for you. Okay, I think it's totally clear. So Hadoop is, this is the only reason why Hadoop is too famous these days in between the researchers, the students, and the developer company, product-based company. They are using Hadoop for analytical purpose and all. Okay, so this definition is clear. Now moving further for the next slide, where we have to focus on what are the characteristics we have in terms of Hadoop. So it has 4 features. The first is reliable, economical, scalable, and flexibility. What is the meaning of reliability? Because there is a concept of data prevention, there is a concept of rack awareness and high availability, which is just going to discuss in the coming slide, where we have to discuss how we are not going to lose our data. Okay, if there is data is going to be lost, our system got failed, how to recover this data. So that feature is there. So in that context, we're dealing with the word reliable. Economical means for this we are not going to pay any licensing fee. We are not going to have any specific changes in our hardware. Whatever the system we are using in our company, the same hardware can be utilized in developing the Hadoop cluster. Okay, so in that case we can say is economical. Scalable means we can let's say you are working in a company having a 15-node cluster system. In coming, the data size is going to increase exponentially. In that case, what we can do, we can add a multiple node. So in that case, we can scale our system, we can enlarge our system, but depending upon the business use cases. Now come the flexibility. So whatever the domain you're working from, flexibility means in terms of platform, in terms of utility, and in terms of languages. So let's say you are a Java developer, you want to work in this big data environment, so you're totally okay. If you don't know anything in terms of Java, you have just a basic knowledge of MySQL or any SQL like environment, so you are most welcome again over here. If you want to know nothing, just want to be in Linux background, networking background, so as a Hadoop admin, you can come into this field. Second good thing is this: this whole ecosystem is such flexible that it can use the code of Java into this, it can use the code of Python into this as in the form of UDF. So now I'm again using a new term UDF. What is the meaning of user-defined function and how to make it compatible with the system? Let's say you're going to have your whole code in a language called Apache Pig. Okay, and in the particular scenario, let's say there will be condition we are not going to have the solution using this particular language Apache Pig. So in that case, what we can do, we can write a code in Java, make a jar file, try to add this jar into this Apache Pig environment, we can do our task then. Okay, so in that case, we can see our Hadoop system is too flexible to work with different platform. Okay, so this is the whole thing. So beyond the theoretical part, a very conceptual part, what we can say, they have some salient feature in Hadoop. We can work both with structured data or unstructured data as well. We have the feature like this. We can hide a scalability feature. Can use in commodity hardware that has been discussed earlier. Fault tolerant means if there is a data backup, data recovery is there, if any system got failed, how to get the data, that should be discussed. Okay, and we can work on data processing. Okay, so data processing means we have large amount of data, first gather it in your file system, then try to process it. So this is the basic design principle of Hadoop. Okay, now the main thing over here, we have to compare what exactly the difference in between RDBMS and Hadoop. So we have certain parameters. The parameters are mentioned in between, like the processing, governance, schema, speed, cost, resource, and best fit uses. So as we know that the RDBMS, example MySQL and Oracle are in market from last 20 years. So they had good governance. They have so many resources for help it out. We have, if you face any issue, just go on Google, type any issue. There are so many blogs. There are so many we can say forum are there. Just they are going to say they are for the rescue for the very same thing. That's the only reason why here we are going to use a word over here. That word is resources. So it's mentioned over there. It is known entity. Okay, and this is growing complex and wide. So I'm not going to say our commodity just too less, or we can say weakening comparative with RDBMS, but yes, we are into growing phase. Companies are adopting us. I just show you the example in Hadoop powered by slide over here, how many companies have been adopted us. Now comes the best fit uses. If your condition is you need the data instantly, means you just transact the money from an ATM, you want to have the message on the go. It means in simple words OLTP, online transactional process, and that case you have to go for RDBMS. But your purpose is OLAP, online analytical process, means we have massive amount of data. The first thing is you have to collect data, you have to clean the data, then depending upon the use cases you have to process, you have to get the meaning out of this data, means OLAP, online analytical process. In that case you have to go for Hadoop. Okay, I think last two topic is totally clear for everyone. Now come the third last topic over there, cost. Okay, so in Hadoop I told you it's an open source environment, so in that case you need not to pay anything. But in MySQL, in Oracle, if you go for the business use cases or commercial use cases, in that case you have to buy the licenses. So yes, cost matters in case of RDBMS. Speed, for discussing speed, we have to first understand what the meaning of schema. When you're going to write a data into MySQL, so there's a concept. First, we have to create database, then we have to create table, and when we are going to create table, we will define the schema. Then we have to insert data. So before inserting data, we have three steps what we have to follow. So in that case, we can say there is a schema required on write time. Okay, but there is no in such case in Hadoop ecosystem or NoSQL database system where we not give any single schema over there. Just go and put your data. Just mention the path and the data file name, and it will go into the task for you. Okay, so what will happen, what is the result of that? In case of this there is required schema on write time or read really fast, means we have a particular knowledge which data has been stored in which column, so it will give our task easy. Let's say in a class I'm going to say I want to find out any particular student, let's say Rahul. Okay, and I know Rahul is sitting in first to third column. I'm just going to class and go and see to the class teacher, just give me the particular student first to third column, you're going to give me the output accordingly. Okay, but we don't have any schema on right time. Okay, there could be three or four Rahul in the same class. I'm going to say, okay Rahul, just come out the class, so there will be four output. Okay, so there will be the issue of replication, there is the issue of data duplication in that case. So in that case we have to go, when we have to read fast, in that case means we have to go for OLTP like process. In that case we have to go for schema on write process. Make sense? Now the governance, again I told you, as it is a known entity, MySQL RDBMS, so it has standard are fixed, the structure are fixed, everything is too good, but we are in the evolving phase, so we are loosely structured over here. Processing means RDBMS can do the processing on the whatever the sets of query they are running, means search star query and whatever the queries which has been divided or defined into MySQL, that can be run under this. Okay, but here we can work with semi structure or data, or we can parallelly do the processing. This is the unique feature, this is the feature which try to differentiate us from the whatever the traditional system we have. So till now what we have discussed, we discussed about what exactly the definition of Hadoop. Okay, what is the difference between RDBMS and Hadoop, and then we have figured out what exactly is the drawback of a existing system, and why we have to move for the Hadoop file system. So this is all for this session. So in coming classes we are going to have a hands-on practical experience. We are going to set up a machine, and we whole set up theoretical part is we're going to demonstrate it using the practical approach. Thank you class.
This conference will now be recorded.
Hello folks, we are moving toward our next session of Big Data and Hadoop Masterclass series. So till now we have focused on what exactly Hadoop is, what is uh, Hadoop file system, what is the meaning of Big Data, and we are going through the prerequisites for this particular course. So I told you earlier, so being in Big Data environment, there is some condition and there are some tool we have to learn over here. So one of them is Linux. You should have the basic idea about the Linux command, how to use the Linux command, what exactly the Linux OS is all about. So we're not going to that much detail in Linux. We just have to focus on the basic command, because whatever the command we're going to form for Hadoop file system or the process engine over there, so that is going to link with HDFS, that is going to link with Linux file system. That's the only reason why we are going to focus over there on Linux. The second thing is this, whatever the command we are going to fire over in Hadoop is going to on the command line in interface or the terminal you can see. So again, this could be a reason why we have to interact with the command line and we have to use the Unix and Linux commands over there. So I'm just going to focus on each and every command that could be possibly going to use in a Hadoop processing environment. And so the commands are listed in front of you. We have to focus on the ls command. Okay, and then followed by the ls-ltr command over there. We have -ls lc command, le command, each and everything, the touch command. So I just going to discuss each and every command step by step, and after this I just going to correlate the whole thing with this documentation what has been mentioned over there. So for this we have to go on our terminal, open our machine over there, and just try to figure it out. So first thing, what is the very first thing we're going to have on this terminal? So let's open a terminal. Okay, in this terminal, the first thing we're going to have a look over there is something is written over there. Okay, so what is the meaning of this? First, you have to understand in Linux. Let's say this mentioned there. Right now, I'm mentioning anything. Let's say I'm mentioning ABCD followed by @DEF. Then it's followed by some like symbol. Let's say tilde symbol, and followed by this each and everything we have dollar. Okay, so there could be a question, what is the meaning of this ABCD, what is the meaning of this DEF, why this tilde symbol is there, why not something else, what is the meaning of this dollar? So over here the ABCD is the user of the file system. So for any user in a file system, what is the meaning of this? So in any file system there could be two users. First one is root user and the second could be the current user. Okay, so root user has all the privileges and the current user has the limited privileges for this particular file system. By default, we are going to log in a file system as a current user, not the master of the system. Okay, so over here, whenever we have ABCD, it means it is a user. Okay, so how we are going to justify it's a root user or current user? For this, we have to go and focus on the symbols. So let's see over here, the user is current user. So I'm typing current user at the rate DEFG. I will explain later on what is the meaning of DEFG. And let's see how to indicate it. If this is a current user, so over here the symbol will be the tilde symbol, and after this we have dollar sign. Okay, makes sense. And if this user is not current user, root user, so in that case what will be happen over there? Root DEFG. Over here the symbol will be forward slash and followed by has. So it means the current user is acting in its own directory, and this is the indication of that. Again, the root user is working in its root directory, and this is the indication of that. Make sense? It's totally easy, it's too simple. Now, what is the meaning of this DEFG? So here DEFG means the system name, or we can say this is the name of host for this particular OS. Okay, let's say my name is Anand. I am working in any company. So the what with my terminal name in my company, it could be like this. Makes sense? If I am not the admin of the system, I am just a current user. In that case, it will look like this for me. I think it's too simple. But if the system is going to be operated by the root user, in that case, it could be written as strictly. Okay. Now we have to figure out the same thing. Over here, my system, your username is mentioned over there. The system name is mentioned over there. So now we have this tilde symbol. So you can just have a guess. This is the current user. Okay. I think it's totally easy. Now moving to the next step. If we have two users over there, means two users has their own identity. Means the user first, the current user has his own directory or file location. In the very same fashion, if there is a root user, it means it has its own directory and file system. So we have to go on our terminal, we have to check it out how to locate the files or directory in this environment. For this, the command is, the command is ls. You have to go on terminal, type the command ls. If you're going to simply press ls, it will going to give you the content, or you can say the data of current user. And if you're going to press like this, ls space forward slash, it is going to give you the content or data of the root directory. So let's have a check. I'm just going to press over here ls. So what is going to give us? It's going to give me the data or folder of this root user, and how to check the path. To change the path with the command pwt. Now we are checking out the content of this particular path. Home Adorika means home is our system and Adorika is the username. Now I'm going to the same task, ls space l. So this is going to give the content of our root directory and how to check the path pwt. Now we are over here, means being in this directory, I'm just going into over the root directory and checking out the command. So let's have a look. Go to the places, computer. I want to be in my file system. Right now I am here. I mean, this is the forward slash over there. So what in the meaning of this forward slash? It indicates we are over here in root. Being in root, we have everything. We have bin, we have root, we have dev, we have home folder. This is the hierarchical architecture of Linux. Inside home, we have users. Okay, what are the meaning of users? We can create multiple users with the name Anand, Abhishek, anything. Okay, so in this, the user will be there. So let's go into this. So Our username is Edureka, so this is there. Inside this, the content of Edureka will be there. Okay, so how we are going to reach over there? The path is over at the bottom. The path is there. We have to follow the same path. First, forward slash, then home, then Edureka, and this is the content of that. Data, desktop, document, download, each and everything is there. The same thing is there in the terminal. Just go and check it out. Control L, and I just pressing ls, so I have the same output. The way it is mentioning over there in our GUI, the same thing is there in Adorica. Okay, data, desktop, document, ABCD, April 21, w.log. So each and everything in terminal as well as in GUI. What is the path of this? For this, I'm just going to type pwt, press enter. This is the path is forward slash root home Adorica, same path forward slash home Adorica. We have the data. Make sense? Now, just go back, close everything, clear the screen. Now, till now what we have covered, only two commands. The first command is ls into the current user file, ls into the root file, and the third command we followed is pwd. So what is the meaning of pwd? It is the meaning of the present working directory, in which directory you are working, and this is just going to throw you the path of that particular directory. Next command is how you are going to know that is what is the purpose of ls, what is the purpose of pwd. So you can check it out of the purpose of any command, or you can just check the manual for this man space. We have to mention the syntax of which syntax you want to inquire of. Okay, we have to mention this. Let's see as example, I want to figure out what exactly ls can do. So I type ls man ls and just go on terminal and figure it out. Control L for clearing the screen. Man and press ls. You see, ls can do list directory contents, and a part of all this, using this sub commands -a, capital A, -author, -block size, we can utilize the command accordingly. So each and everything has a different meaning. We just go into each and everything. Okay, let's say I want to long list. Here ls just give you the name of file and folder. So here you're not in a condition to know which one is your file, which one is the directory. So in simple, we can see which one is the data over here, which is in color mode. You can say their directory, and which are in black, you can say is a file. But this is not the right approach to say like this. So the traditional approach, ls space -l. The meaning of -l is we are long listing the output. This press enter. This is the whole detail we have. Means it has the name of the data, the timestamp, the size, which one is your user and group, and finally what sort of permission we have. So before moving that, we have to focus on which one is your file and which one is your folder. Let's say I told you which of the file which are in color, they will be termed as directory, but be very specific. Just go on the very first 10 bits over here and figure out the very first bit. If the very first bit is D, it means it's a directory, and if it's not D, it's hyphen, it means it's file. Make sense? So whenever you have to find out which data is file and which data is directory, don't go on color code, just do ls space -l and go and figure out which is the first bit. If the first bit is D, it means the directory, otherwise it's a file. Okay, so what is the main difference? A file could be text file, word file, where we can cat operation can be performed. So this is how the man is going to act. Again, let me showcase you. Control L. I have to do the next task. So till now what we have covered, just try to let it down. We covered the ls. We covered the next command over there, means ls space -l. Now till now we know like there are command we can use over there. Now trying to switching the user, means right now we are working in current user, I want to switch my user. Okay, so for this command will be su and the username. Let's do the same task over here. Su means right now I'm working in Adureka, means current user. I just switch my user as a root, I'm just going to type root over here, press enter and enter the password of my system. So what will happen over there? It has been changed. Means the user has been changed from current user to root user. Again, the system symbol has been changed from dollar to hash. Makes sense? So the same thing has been mentioned earlier. If it will be root, it will be act as a root and the symbol will change. Makes sense? Now, I want to return back. Means I just want to return my role from root user to current user. So we have to mention the current username, as simple as that. Now we are returning back as a current user. Now in Linux, we can create directory, we can create folders. So how to create directory? The command is mkdir. What is the meaning of mkdir? Just go type man mkdir. So this mkdir is going to use for creating a directories. Okay, so press Q at the bottom, getting exit from this. I want to create directory. Let's say mkdir, and the directory name is anything. Let's say India underscore one. Let's check it out. Is directory there or not? Press ls. Now we have this directory over there. India underscore one. It's there. In the very same fashion, what we can do, we can create file. Before creating a file, there are so many options. So we can create the file with the data, without data. Means, let's say there is an option you can create a file, or you can say you're going to create an empty file. In that case, we have the command touch. So touch will going to create a blank file. So let's check the manual man touch. Okay, and I just try to write the command touch and the file name. Let's I'm going to create a file name named as Bharat. Press enter and do cat. So cat will just going to display me the content if it has any. So no any content is there, means we're just going to create a blank file. Now what I wish to do, I wish to insert some data into this blank file Bharat. For this I have to use a command nano. Nano is a command for creating a file. I'm opening the existing file. What you can do is create existing, you can open an existing file or new file using the same command. Okay, so I'm using the existing file bharat, press enter. So as I told you, it's a blank file, nothing is there. Now I want to type hi, how are you? Are you getting it? And I want to exit from this. So for getting exit, we have a command at the bottom, Control X for exit. So I'm pressing Control X. Let's say you want to change the file or you want to save this file. Yes, I want to save the file. Press Y and press enter. So you are exiting from this nano terminal. Now you want to show the content of this Bharat file. So type cat and the file name and press enter. So whatever we have been typed, the same will be displayed over here. Make sense? So now what we try to learn over here, we try to learn three things. Let me put it down. We type the command mkdir for creating a directory. So you have to mention mkdir and the directory name what you want to create. Then we just try to create an empty file. For this, we have the command touch space file name. Now you want to create a file along with the data. For this, nano space file name, and in nano you have a command like control plus X for exit, and the second command will be like you have to press yes after this, and then you have to press enter to exit from the particular nano terminal. If you show the content, you want to showcase the content, in that case you have to type the command cat and you have to mention the file name. So whenever I'm going to use the word file and directory, both have the identical meaning. In file, we can perform the cat operation. In directory, what we can do, we can perform ls operation. So ls cannot be performed on file. So ls means we have to perform ls and the directory name. It is mandatory whenever you want to perform. This makes sense. Now, going further, what next we can do? So till now, I want to create a, I just created a file named as Bharat, and in this we have a data. Now I want to copy this file from a new file. Okay, let's say just press enter. What we have a folder India. So what I want to do, I want to copy this file Bharat into India. Just go into this India folder, check it out what exactly into this. So just getting into any directory or folder, we have a command cd. Cd means change directory, and we have to mention the folder directory name. So I want to go into this India named folder and just press enter. Right now I am into India because instead of tilde, this folder name is mentioned over there. How to check it? Just type the command pwd. So right now this is the path I am into this India one folder. Now I want to check it out. It is there. Is there something into this India folder? For this we have to go and press ls. Nothing is there. What is the agenda now? My agenda was I just tried to copy this Bharat file to this India folder. So let me do the same thing. Go back to the default terminal and press ls. Now this is the folder name India 1, and where is the Bharat file? Here is the Bharat file. Okay, for this command is cp. Cp means copy. First you have to mention the source. Okay, what you want to copy? I want to copy Bharatian file, and where you want to copy? I want to copy this file into this folder India. Press enter. Okay, now check it out. Go inside this India named folder, do ls. Now this file Bharat has been copied into this. Okay, now you can show the content cat Bharat, press enter. The data has been copied. Make sense? Now the same way we can perform cut operation, like the way we are doing in Windows, copy and paste or copy and cut. Okay, we can say move. So the cut operation will be termed over here as mv or move. So mv has the same meaning as rename. Let's say I want to rename it. So you have to press what we want to rename Bharat with Bharat 1. Press enter ls. Now this Bharat has been replaced with Bharat 1, but the content will remain same. Means I just try to rename it, or in simple we can say just try to cut the file. As simple as that. So cutting a file or renaming a file, for both tasks we have to use the same command mv. Okay, so just try to list it down what we tried over here. So we try to perform the first thing cd. Cd stands for changing directory. You are in a certain, let's say you are in directory A, and from A I want to go into B. So what I have to type cd and the directory B. As simple as that. Okay, now next command I tried to explain is copy command, and for this syntax is cp. So how to write a code for this cp, and you have to mention the source file path or name followed by the destination file path or name. Okay, then you guys to for next command cut, and cut has the same meaning as rename, and for this we use the command mv, and the same thing we have mentioned over there means copy the destination and paste the destination and source file path over there. Till now we just try to learn the how to copy a file and how to cut a particular file or rename it. Make sense? Now we can create multiple directories using there, like in mkdir folder, inside folder you can create accordingly. Let's see what we try to do. We try to create a folder in India over there, and you want to create another folder, so you can type mkdir. Okay, I tried a folder over there is India underscore 1, and I want to create again new folder into this India underscore 2. So accordingly you have to give the path. You have to go into create directory sequentially. Let's have a demo. So I'm just going to type the command mkdir. I have a folder A. Inside A I want to create B, under I want to create C. Press enter. What is C? You can't create a folder over there, so you have to use some sub syntaxes hyphen p. Press enter. Means hyphen p means progressively. Okay, just go and check it out. CDA ls. Inside this we have folder B, and inside B what we have, just go to B and press ls. We have C. So right now where exactly we are, press pwd, we are into this folder B. If you want to go inside C, cdc, and finally you can check the path. We are into home at Breaker. Inside the last folder is the ultimate directory where you want to be. Okay, the same way we can use, there are multiple commands we can use. There are multiple main command and sub command we can use in Linux. So over here, how to use, check it out, man mkdir press enter, and I use the parent of progressive file. So if there is a file existing, you can use the next command accordingly. We have version command, we have so many commands we can use. So whenever you want to perform any type of operation, just go and type man and for the syntax name. So it's going to explain it. mkdir is just going to make directories in a particular location. It's too simple in Linux. Okay, you can use date command to check the like what is the system date over there. Okay, who am I? Just going to let you know the username, the current username I told you earlier. Okay, accordingly we can find out so many things, so many fancy things over there. So Linux has again a very vast field, so we need not to go inside Linux because the whole agenda was we are here to learn how to. So whatever the command is required for this particular task of Hadoop, we have to focus on that. So let's say we have a directory over there. Just go at the back and I want to create a directory. Let's say I have a directory named as India1. Okay, and I want to remove it. If it is empty directory, it is simply going to delete. But it has something. It has a file. Just go into this India1. Okay, ls. So we have Bharat. I want to this. I want to remove this file. So I have to type rm Bharat. Press enter now. And nothing is there into ls. So I just tried ls command to check it out. The way I'm typing over here is going to give me the output. So whenever we have to delete a file, we have to use rm space the file. If you want to delete directory, you type rmdir. If the directory is empty, it is just going to delete the directory. Make sense? I want, let's say there are two options for cd. You can type cd, just go back to default location. You want to go one step back, type cd double dot. How to explain it more? CD A, inside A we have B, CD B, ls. Now inside this we have C named folder. So right now where we are into C. I want to go into the B directory. So what we have to check? CD space double dot. So CD space double dot is just going to let you know at the one step back. Now I want to again to B to A, CD space double dot. Okay, what is in your CD? CD is just going to let you go at the default location. Make sense? So CD space double dot has the meaning of going one step back. Okay, it is easy. Now moving further for the next command. Next command is like chmod. What is the meaning of chmod? Chmod means changing the mode of any file. So what is the meaning of mode? On whenever we are going to say the word data, so the data means of three types. Data could be a file, or it could be a directory, or it could be a system file. Okay, on particular data, what sort of operation we can perform? So on this data, when I'm going to use operation, only three operations we can perform: read, write, and finally we can execute this data if it is executable. Make sense? Now, who can perform this task? So there are only three person or three utilities that can perform the task. It could be user, group, and others. Okay, so who is user, who is group, and other? Let's see. You are opening a terminal and it has name. Let's say Anand at the rate whose name, and the current user over here. So tilde symbol will be there followed by dollar. And I'm going to create a file nano abc. So over there, who is the user of this file? Anand is the user of this file. Means it's the user as well as the owner of this file. Makes sense? If Anand is going to share this file to a known group, this company group, in that the whole group will be the, like we can say, taking care of this file ABC. If this Anand is going to upload this file on YouTube or any open source platform, so they will be termed as other. Now, what sort of permission we can give on this ABC file? If this file is a text file, we can read, we can write, but Anand is, I don't want anyone to change my data. What sort of permission it has to give to the others? Only read permission. You can't change it, just read it. If I want to give you, like if Wikipedia page, you want to read the file and write also, in that I have to give the read and write permission both. So how to check it out? What sort of permission we have? So for this we have to command is ls space hyphen l and you need to mention the file name. Okay, just go on the command. So let's see, I have a file. Just go on terminal, press ls, have a file abcd. So over here, this is the meaning of this. ABCD is the file name. This is the timestamp. This is the username. Having created this particular file, this is the current user. 62 is the size of the 62 bits is the size of this file ABCD, and it has a permission. It is altogether 10 bits. So let me explain each and every bit. So here we are discussing about the chmod command. So before discussing about the chmod command, we have to understand the permission. So here are 10 bits 0, 1, 2, 3. Okay, let me write it like this 4, 5, 6, 7, 8, 9. Okay, the first bit is going to explain about what is the type of the particular data, means data type. If this is a hyphen, it means it's a file, or if it's D, it means it's a directory. Make sense? ABCD is file or folder. It is going to indicate it by the first bit. So this ABCD, the first bit is hyphen. It means this ABCD is a file. Make sense? What next? Now we have to focus on what is 1, 2, 3. What is the meaning of 4, 5, 6, and next 7, 8, 9. So this is the permission what we have for user, what sort of permission we have for group, and finally we have to focus on what sort of permission we have for others. Okay, so what is the permission we could have? This is a file. As mentioned earlier, the first bit is a hyphen. So user can read the data, it can write the data, or it can execute the data. If user is going to send permission to the group, it can also perform only 3 tasks, not more than this. Okay, this is the maximum permission what a user can perform on data. Make sense? Now let's say you are a user, you want to say like this, user has only read and write permission, no any execution permission. Same for read write permission for group, and other can only read, no write, no execute. So in that case, this is the case. This is the 10 bits. How it will look like? Let's check. The same way, user has a read write permission only. The group has read write permission only, and the others has only read permission. Okay. So this is the meaning of that. How to change it? How to manipulate it? So for you and me, it's read means R, write means W, and X means execute. But for Linux system, whenever I want to perform the read operation, it means 4. It is already defined. If I want to perform the write operation, it will be linked as 2. If I'm going to perform the execute operation, it will be termed as 1. So let's figure it out. So I want the user, means the first 3 bit. It can only read data or write data. I want to change it. I want a user can only read the file. It has no any write permission, no any execute permission. How it will look like? It will look like 4, as a read. No write means 0. No write, no execute means 0. And altogether, what is the value? 4. Makes sense? Now, for group, I wish like the group can have only one permission. It can write data, not read, not execute. So how it will look like? No read means 0, write means 2, no execute means it has the permission like 0. Finally, we have the values 2. And over here, I want like others can execute only. Let's say you are a software development company, you just create a software. You don't want to share your source code, just give the code, just install and run it. Yes, you just want execute over there. So how it will look like? 0, 0, and 1. Final value is 1. So how to write it as the whole together? What is the value for this file? So the value will be 4, 2, 1. So if I'm going to give the same value to the file name abcd, so the permission, the mode of the particular file has been changed. So how to write this command? The command will be written like sudo chmod, the value 421, and the file name abcd. And after this, we have to go and type ls space -l and the file name abcd. The permission will be displayed over there. So let's do the same task in terminal. Over here, I just initially type ls space -abcd. We have certain permission. Now I'm trying to perform the chmod command 421 as mentioned in our explanation. Press enter and enter the password. And now I have to type ls space -l and the same command. So now you have the output: read, write, and execute. Make sense? And this color change displayed, there is some change in our data. So can we cat it? Obviously, I am the user, I am the advocator, and I have the read permission. I can read it. But what happened? There is no read permission to me. Means as a user, means over here, I am the user. I don't have any read permission. I have only write permission. What happened over there? The value will be changed. It will be 2 over here. The final value will be 2 to 1. Okay. So if I don't have any read permission, means a user don't have read permission, so we cannot perform the operation of cat. What is the meaning of cat? Cat can display the content of the file. It means it can read the file. If I don't have the read permission as a user, I can't read the file. So let's do the task. ls, and I am going to check it what exactly permission what we have for abcd. I want to change it. So for this command will be sudo chmod. Instead of 421, I'm typing 221. Press enter. Check it out again. Now the permission has been changed. Earlier the user had r permission, the starting 3 value. Now we have r has been removed. I just give only write permission. So I don't have any read permission. So I cannot do cat. Let's try. What is it? Permission has been denied. I cannot read it. Makes sense? Again, how to enable it? So instead of 2, I have to give the permission of read. Check it out. Now I have read permission. Now I can perform cat operation. This is the meaning of chmod operation. So in coming classes, in coming Hadoop session, we have to focus on those. So there are many more commands we had to use in Linux. So as per the requirement, I'm just going to explain during the Hadoop session. Each and everything will be crystal clear over there. So I think it's totally easy. We have to just go through this video, practicing your own system. It's too easy for you. If you have any doubt, just write a mail or ping us in the chat box, and accordingly we're going to respond you back. So the next session will be the Hadoop command. Over there, we are going to focus in detail about that. So each and everything will be covered into command line mode, and we have to go the whole hands-on session of big data and Hadoop using the Apache Pig, Hive, and Java. Thank you guys for your time. To commands over here, we have to focus on command over there. So here the commands have been categorized into creating a directory into HDFS. There is a first command over there. Then we are going to move further for listing the contents in the present in the directory. Then we have to learn how to upload a file into HDFS. Then again moving forward, we have to know how to download the file to local file system. After this, uploading and downloading the files into SDFS file system, we have to go through and sync the content in SDFS. For this, we have to use the command cat, and again we have to copy a file from local file system to SDFS, and there is do the reverse vice versa, means we have to copy the file from HDFS to the local file system, and we have to again learn how to remove directory. So there are so many commands into HDFS. We are going to proceed each and every command step by step. So before this, going to moving further, we have to go and learn how many commands we are going to learn over here. So let's proceed further. The first command, before using each and everything what I had mentioned over there, first command is to check is Hadoop is working or not. So we have to check Hadoop up and running or not. For this, we have tried the first command in our terminal. Over there, you have to go and type sudo jps to check it out is the daemons are up and running and not. So whenever I'm going to use the word sudo jps, it means the default Hadoop daemons, that is name node. The second one is data node, the resource manager, node manager, job history server, and by default Java process JPS should be up and running. If these daemons are up and running, so in that case we can say yes, my Hadoop is working fine. If everything is working fine, in the after this we are going to use the whatever the commands or syntax we are mentioning over here. So practicing everything, just go in my machine and try to log in over there. So I'm into machine of big data, trying to log in using my password and press enter. Let the terminal come over here. It will take hardly 3 to 4 seconds to the system get started. Let's wait for that. So the command has to go different section into Hadoop. So the whole command will be categorized into two parts. First part will be the developer commands, and the second command will be Hadoop admin commands. So what is the meaning of developer command? What is the meaning of admin command over there? Let me explain this. Admin command is such a command which have to deal with the system configurations, RAM utility, and the whole sort of network setting, adapter setting. In that case, we have to focus on the admin command where we have to deal with the file system, the safe mode and all. In that case, we have to go on simply on Hadoop admin command. Developer command is all the file we have to deal with data, putting the data into local file system, HDFS file system, running a jar file, running the Hadoop basic syntax and command like Hadoop help command. Okay, so in that will becomes in the Hadoop developer command. We are going to discuss each and every command step by step. So first, we have to check the machine is up and running or not. Now, so machine is ready. So we have to open our terminal because each and every command is going to fire in the terminal. So let me open the terminal. Let me zoom it. So the first thing we have to check the Hadoop system is up and running or not. So for this, we have to go and type the command sudo jps and enter the password of my system. So we have the daemons are working. It means the resource manager, the data node, the node manager, and name node, they all are up and running. It means the system is working fine. Let's say in a case the system is not working fine, that the command sudo jps is not going to throw you the output like this. So what will happen? So daemons are not working in that case. So let me go to the admin command over there, and I have to stop all the daemons. So in that case, what will happen? The daemons will not going to act. We don't have any daemon up and running, means we are not going to interact with the web UI of name node. So right now over this command everything is working fine. So let me open the web UI of name node, and we have to explore the data as are there or not. So let me open the browser. We have Hadoop name node over here. I'm just going to click on that. So the name node daemon is going to host it on my local host, my host system name, on the port number 8020 this name node is acting, right now is active. Okay, if it's active means we can go into the browse file system and we can explore what sort of data we have. Okay, it's totally fine. Let's say in a case I'm just going to close each and every daemon. So I have to go to the Hadoop admin command. I told you there could be a two category of command. First will be developer command, the second will be the admin command. So I'm going to demonstrate you the first admin command. For this, the command is sudo service Hadoop hyphen master, and the command is stop. I try to stop all the default services of Hadoop. So it's going to stop each and every service step by step. The first service is going to stopping is node manager, then resource manager, followed by data node. After this, we have name node that has to be closed. Accordingly, whatever service which are up and running earlier, the whole service is going to stop step by step. And after this, we have our default terminal. Now, being over here, I'm just going to type the same command sudo jps. So it's just going to say that there is only Java process is up and running, and there is no any services related to Hadoop is up and running. So what is the impact of that? So let's go to the browser. Over here, earlier this name node was up and running. I'm just going to press the same thing, Hadoop name node. Let's check what will happen. Let's say unable to connect means the name node is not functioning well over here. So we can't browse the data which are into name node over here. Okay, so try to restart the service. For this, you have to type the same command. Instead of stop, we have to type the command start and press enter. So just have a look over there. So it's just trying to start the default services, the starting name node, the starting data node, and it's going to mention each and everything. So each and every services of Hadoop is going to start into defined, we can say in user lib Hadoop 2 into log in yar folder. So over there each and everything has been defined. So let's go and check it out. The daemons are up and running or not. So press the command sudo jps and pressing enter, we have all 5 default daemons are up and running. So let's check again. Go to the browser, click on the Hadoop name node. We have our on localhost 8020, the name node daemon, or we can say process, is up and running. And over there we can browse our file system. Okay. Now we have another error over here. Error means there are name node is in safe mode. So what is the meaning of safe node over here? Is again an issue for related to the data services over here. Is again comes into the category of what we can see the admin command. For this we have to write a command. Let's go over there. Before this, what we can do, we can figure out the command, what is the meaning of this. Let me explain the whole thing via Google so that you can also explore the command, because practically being a fresher, you can't recall each and everything. So just whatever the error you are getting, just go and type on Google. It will going to give you the output, or you can say simply name node safe mode, or you can type safe mode leave. Okay, and you can just go on Stack Overflow, or you can figure out so what sort of command are provided over here, and using this you can use the same command accordingly. Okay, so there are so many commands over there. Hadoop fs safe mode hyphen leave, this command you can type. Okay, Hadoop dfs admin hyphen safe mode leave. Okay, so there are so many commands we can use over here. Let's check they are working or not. So the command is Hadoop dfs admin. So over here we have to very much specific on that case. So what are the command over here? The dfs admin, there is no new space. So whenever you're going to type the command, make sure where is space, where is not space, where are hyphens. So the command is Hadoop dfs admin hyphen safe mode, and you have to type the command leave and press enter and just wait for the output. What is safe mode is off. So when safe mode is off, we can, this error 500 will be resolved. Just go and press again and press on the browse file system. Now everything is up and running. So whenever you're going to deal with data name node and data node, in that case there could be different problems what we can face over there. So till now what we have discussed over there, the first command we covered is sudo jps to figure out the command the system daemons are up and running or not. And after this we try to follow two more commands. Let me write the command for you so that you have the idea of the cheat sheet. The second command was we have to start and stop daemons. So the commands will be sudo service Hadoop hyphen master stop, and you can type start accordingly. The next command we try to follow is to leave the safe mode. So the command is as follow Hadoop dfs admin hyphen safe mode leave. Okay, now so till now I come in a condition like in my system Hadoop is there and Hadoop is up and running because the daemons are running, and there's no any issue of safe mode over here, means we don't have any issue of error 500. Now we have to find out the next command, means we have to find out in our file system. So what is the default file system we have? The default file system is hdfs, so we have to go into hdfs and list out what sort of data we have. Okay, so for this we have to type the command hdfs dfs hyphen ls space forward slash. Okay, so just go on terminal, control L for clearing the screen, and type the command hdfs dfs hyphen ls and place forward slash. So whatever the data means it could be a file directory that will be going to listed on the terminal. Okay, so you can find the data using this command line. For after typing this command you can go on web UI mode and you can find the same thing. Started in fn hisar latest, the whole file directory has been listed over here in the very same fashion as it is in the web UI page. Now after listing this data, like we have just listed the what sort of data we have in our default file system or html file system, you can explore any data. Let's say over here there are lots of system we have, so just figure out which of them are file and which of them are directory. Let's say we have a file fn.txt, so it is a file, means we have to show the content what exactly in this file fn.txt. So for this we have to use the command. Let's go over there and you have to mention the command cat to show the content, and you have to mention the file name. Press enter. So whatsoever the content into the file fn.txt will be displayed over there. So let me give you the output in GUI mode. This is the data what fn.txt carries. So the same data is going to display into command line mode as well. So let me figure out what we did. We try to figure out two things. Try to first list out the data. When I'm going to say the word data, so you have to try to understand two terms. The data could be directory or it could be a file. When we have file, so what we can do, we can just try to perform the cat operation over there. So for this we have to write the command hdfs dfs hyphen cat, and we have to mention the file name. And whenever you perform the list operation, so you have to perform hdfs dfs hyphen ls, and you have to mention over there directory. Make sense? Now so till now we are performing the ls operation, we are performing the cat operation. What next we have to perform? Let's see, we have to put data from one file system to another file system. Let's say by default we are working in our local file system, or we can say Linux file system, where we have a file. Okay, and the file name is a.txt, and our agenda is we have to just copy this file from this local file system and paste it into hdfs file system. So how to do it? So for this the command in Hadoop is hdfs dfs hyphen put, and you have to copy the source path. So from where I want to copy the file from the local system, so I have to mention the path of local file system path for the data, and I have to finally mention the path of hdfs. Make sense? So one thing I just want to recall you that what is the meaning of put? Okay, so you can use put in two way. Either you can type put, or it is equivalent to copy from local. So the same command can be written into two ways. Over there, let me write the command again for you. So instead of this put syntax, you can type over here copy from local. It will going to do the same task for you. So just try to demonstrate the same thing over here. Go into the machine, Control L. So over here, I'm just trying to create a file for you. So as we know in our last class, we have been discussing about the Linux command, and we came to know about this. Using nano, we can create a file. Let's say I'm just going to create nano, and the file name is abcd. Just press enter, and I'm going to say data or sample data for copy the file into HDFS demo data. You can type anything. Control X, Y, enter. So this file is in this local machine. So right now just create the file abcd. So having the content of this particular file, we have to use the command cat space file name, and whatever we just write over there, the same has been displayed. So using cat command, we can just display the content over here in terminal. Now we have to figure out what is the path of this particular file. For this, the command is pwd present working directory. The file is home and Eureka and followed by the file name. So what is the path of our file system over there, or file you can see? So here, so the absolute path is, first we have to mention the home, username, and the file name. This is the source path we can see. And where you want to copy the data, I want to copy the data into the root directory of HDFS. So I have to mention the sink or destination path of HDFS. Make sense? So let's do the task. So just go into the machine, Control L. What is the agenda? We have to copy a file from local file system to HDFS file system. First, we have to go inside HDFS file system, check it out. Is there any file termed as ABCD is there or not? For this, I have to go to name node, click on browse file system. I'm just going to figure out is there any file is pre-existing with the name of ABCD. The answer is no, I don't have any file. Just try to do so. So over here, I have to type the command hdfs dfs hyphen put path of the source file, it is home, and Eureka, the username of your computer, and abcd, the file name, where you want to copy the root directory of HDFS, and press enter. Now everything is fine, so it's not going to throw any error. It means everything is good. Now we have to check it out, this file is there or not. For this, you have to go to your file system, just refresh the web UI. After refreshing, you will going to find this abcd file is there on the same day, current day. Now you can just go click on this. So we have the data what we have just typed into the file system. The same data has been copied from the Linux machine or local file system to the HDFS file system. In the very same fashion, if you have to do the reverse operation, means let's say you have data in your HDFS, you want to copy the data from HDFS to local file system, so you have to type the command copy to local. If you don't want to type such a big command, so instead of this, you can use -get. Make sense? So you can just try and practice the same command. It will be so easy for you. What you have to mention over there. Instead of this put, whatever I type -put, here you have to just replace get. You have to mention the source path. So our source path will be HDFS. Just reverse the thing, and the destination will be a local file system where you want to put the data. So how the systems will work? The syntax will be HDFS DFS -get, and you have to mention the source path of HDFS, followed by the destination path the path of local file system. So this is how the get command or copy to local command is going to act into HDFS. Now moving further, so till now we have covered the cat command into HDFS, the ls command into HDFS. We copied the admin command over here, and we just try to follow the whole command over there. Now let's say you want to remove any file system or file or data in HDFS. So for this we have the command SDFS dfs hyphen rm and followed by the file or data name. Okay, let's say we have a file abcd and I want to delete it. Okay, for this command is hdfs dfs hyphen rm and followed by the file name. Press enter. So what to say, deleted file abcd. Let's go to the web UI, check it out. I'm just go to the Hadoop name now, browse file system, and just figure out I don't have any file over here with the name of abcd. So we're just going to remove the file just now. I think it's too easy. So each and every command in Hadoop is too easy if you are familiar with Linux. So you're not going to face any single issue over there. Okay, one more thing you have to notice over there. Instead of SDFS TFS, you can use Hadoop FS. Means the syntax Hadoop FS is equal to HDFS DFS. So how to make a command? So we can type the command HDFS DFS hyphen ls. It is equivalent to Hadoop FS hyphen ls // So let me demonstrate you. Hadoop. I'm just going to go on terminal and type the command Hadoop FS hyphen ls /. It is going to give me some output, and in the very same fashion I have to replace this command with HDFS and DFS. Press enter. It's going to give me the same output. Makes sense? So you can use either way, whatever the way you feel comfortable, you can use the command. It both have the same meaning. Okay, now go to the document and check it out what we have covered till now. So over here we just try to cover the creating the directory file. So I'll just go and create directory. So for creating a directory, what we have to do, we have to use the command in Linux for creating directory mkdir and followed by the directory name. In the very same fashion, if you want to perform the same command into SDFS or Hadoop, so we have to type the command SDFS dfs hyphen mkdir, and I have to mention the directory name starting with the root. Okay, root is the default destination where the data is going to store into name node in the directory name. So simple. So again the same thing I want to do. So I just want to go over there HDFS DFS hyphen mkdir. I try to use a create a directory. Let's say the directory name is India. Okay, the same thing. So let me go to my terminal and clear the screen, and HDFS DFS hyphen mkdir, and I have to mention the directory name. Let's say is India. Press enter. Now I have to go to the web UI and check it out if we have such folder has been created or not. I just press it. We have the directory and as over here, and this file has been created on the very same time. Now this is an empty directory. It contains nothing. When I'm going to click on that, it will be empty directory. Okay, now I can put the data, copy the data, whatever operation you can perform, that can be performed over here. The first task clear. I think it's totally easy. SDFS, TFS or Hadoop FS, whatever you feel comfortable, you can write hyphen mkdir and mention the path. Then you can fire the command ls. We just covered this. We just covered the next command hyphen put, and we can cover the same way hyphen get. So all has been covered over here. Now we just try to cover the command cat. So the cat operation can perform. It is again going to displayed earlier, and you can copy the from local the same way hyphen put command. You can type accordingly and copy to local is the meaning of, like we can say the get command. And finally you will just try to remove a directory or file of anything from file system or default file system HDFS over here. So each and everything has been displayed. Now one input command, we just try to have a demo of that. List command is covered, git command is covered, mkdir we just have a demo of that. Then we cover the cat command to display the content of a particular file system over there. Copy from local has been covered, copy to local has been covered, remove a file has been covered, means we have to copy hdfs dfs -rm for removing the file and mention the path of the file. Okay, then we have fsck. We are going to, in coming classes we are going to clear this. If we have file system check command, in that case we can use the command fsck over there. It's totally easy. No, if you're going to face any issue, in that case we can just go and cover the same command again and again. Then you can use the help command over there. So for this we have to just go on terminal and type the help command over there. The way we are typing over there means hadoop fs-help. So whatever the support we can get from the hadoop, it will going to display it over there. For this, just go on terminal and type the command hadoop fs-help. Press enter. So what we can do in hadoop, that each and everything will be going to display over there. Means over there we can perform mkdir operation, we can perform move to local, copy to local operation, we just try to perform put operation, we just try to perform rm operation. So what sort of operation we can perform in hadoop, that has been displayed over there. Makes sense? It's just like a directory. One more thing, can try hadoop fs and press enter. So what sort of command we can use using the command hadoop fs, that will be going to display. So let me describe it again. Control L. You can type hdfs dfs. So that many command in front of you, like hdfs dfs -conf -file. Okay, hdfs dfs -append, chn group, chmod, chon, copy from local, we just try to perform it, copy to local, count, cp. Okay, each and everything can be used over this command. Okay, now let's say this condition, you have to run the jar. In that case you have to type the command hadoop jar. So what's the meaning of this? Let's say you have a code in Java into this jar file and you want to run this jar file. So in that case we have to write the command like this. So till now what we're trying to do, we're trying to do the data operation. Now we have to perform the code operation. So in that case the command will be hadoop jar followed by the path of the jar file. Okay, jar is going to on which data, we have to mention the data file, or you can say input data file. And finally whatever the operation is going to perform, based on that whatever the output we have, so we have to mention the target directory path. It is into hdfs. Okay, so when you're going to perform our hands-on session for whatcon program, in that case we are going to cover. So this will be covered in our session number 6. Okay, when you're going to have a demonstration of word count. Okay, so just focus on over there and just going to type the command. The same command will be going to use over there. Okay, but till now this is the command we have to follow over here. So each and everything is covered over there. It's all simple. So for this we have to focus on only one thing. You should have the basic idea about Linux. So just I uploaded the video of Linux commands in our earlier session. Just go and check out the Linux commands. If you find any issue, any difficulty over there in this command, just write a mail. We're going to update you, or you can just put your comment in the chat box, or you can put your comment into our this review or feedback utility option. Thank you class for this class. I'm just going to close the session. Work what exactly MapReduce is and how to do the whole coding into MapReduce, we have to discuss over there. So this is the official documentation of Apache Hadoop. and here I'm going to refer Apache MapReduce tutorial. So where we have discussed about the purpose of Hadoop, what is the meaning of MapReduce, then we have moving further what is the mapper class, reducer class, and the counters and partitioner. That term have to be discussed. Then we have to go for job configuration, which sort of tool dependencies we have to add in our Java code, and finally we have to move further for what is the splits. The meaning of that means there could be two type of splits: input splits and output splits. What is the meaning of record reader? Each and everything we have to define, and at the end I have to give you a demonstration or a simple program use that word counter Java. So in that particular program we have source codes, and we have to explain the whole source code in Java and try to make you handy over that. So first thing, like what exactly the MapReduce is all about. So Hadoop MapReduce is a software framework. So what exactly MapReduce is, you should have an idea over there like this. It is a framework. So Apache Hadoop MapReduce is a software framework for easily writing application which process a vast amount of data in parallel on large cluster on a commodity hardware. The word commodity hardware means you can use the whole processing on your laptop. For this, you need not to buy any specific machine. The laptop you are using having a 4 gigs of RAM or 1 TB of capacity of hard disk, in that you can perform the whole task. Okay, so basically MapReduce job usually splits the data into different chunks, and we can process the whole chunks parallelly. So the whole task of MapReduce is going to split into two parts. The first will be a map task, and the second could be a reduced task over there. So we have to go in detail what is the meaning of map task, what is the meaning of reduced task, using the coding and all, and we're going to explain each and everything. And finally, after processing the whole task MapReduce using the parallel processing, we have the data, and the data is going to store in our distributed file system SDFS. So we have to go inside our SDFS file system, check it out, we have the output or not. So we have to perform the whole task over there. Whenever we are going to perform the process like task, like we have to execute the code, and that time the daemon is going to act up and running. The daemon name is resource manager, so we have to focus on how many daemons are there. So if we have to perform a MapReduce framework task, in that case two daemon will come in a picture. The first will be a master, so the master will be resource manager, and the second will be your, you can slave or worker, that will be termed as node manager. Okay, so we have to go again and go to look it out how exactly we have to do. So performing this MapReduce job, so for this we have to create a jar file. Means the job, for performing this job the client is going to submit this job using the jar file, and finally we have to execute the jar file over there in Hadoop environment. This is the whole flow we have to do. So this is the code in front of you in Java. So over here we have to import the packages in Java. The initial two packages will be the Java packages for input, output, and string tokenization. Remaining all packages are from the Hadoop package for configuring, for path building, for defining data types. The data type could be int writable, long writable text. Then we have to define our map job, MapReduce job, where we have to define our first class, mapper class. Then we have to define our reducer class over there, and at the end we have output. So we have output in two format. If the data is of any type, we have to define the file input format. This could be text, it could be binary, it could be sequential file. In the same fashion, depending upon the output type, we will define the file output type. Then we have to define our main class over here. So you can write anything over there, and then into this we have to define the mapper class. Okay, so the property of mapper class which has been defined over here has to be extended by the map. Okay, so public class, static class, map, you can define any name, you can name it map, you can rename it anything. We can write like this. Then again we have to define our reducer class. So here the reducer class over there, and this package has been imported earlier. Property of reducer class has to be imported by the public class of map, and we have to write the code for this. And at the end the job is going to submit it, and we have the output. For running the whole code of Java, we have to export this code from our IDE into jar file, and we have to run that jar. This is the whole execution. We have to explain each and everything step by step. This is the basic thing. We are going to focus on that. So let's start our session so in detail and in so practical way. So over here, our agenda was we have to discuss Hadoop MapReduce framework. So what exactly Hadoop MapReduce framework is all about, we have to focus on that. So this is the topic what we have to cover today. So Let's proceed further. So the agenda was we have to process data. So for processing data, we have two tools in Hadoop ecosystem. The first could be Apache Pig and Apache Hive. If we are moving further from MapReduce to Yarn case. So before proceeding further to Yarn, we have to focus on MapReduce. So in that case, instead of Pig or Hive, we are going to use Java code, and this Java code is going to act on the data which is present in SDFS, and after processing whole sort of activity in SDFS, we are going to have the output. Okay, this is how the whole engine will work. So before proceeding further, we have a question. So this question is in front of you. The secondary name node is a hot backup of name node. You have to say true or false. So the answer will be false, because the secondary name node is the most is not the hot backup of that. It's just having the checkpoint for the mechanism for Hadoop ecosystem over there. So here we are going to focus on where to use MapReduce. So whenever you have forecasting like a statement, you have to do a de-identify like system. When you have to write the code to process the data, in that case we have to do the MapReduce task. So what was before MapReduce? So before MapReduce, the process, the whole sort of activity was governed. But for governing those whole activity, we have the idea. If we have a very big amount of data, so first step is we have to split the data into different chunks, and on each and every chunk we have to perform the grep operation in Linux, and depend in every splits is going to give you the data depending upon the matches or depending upon the respective queries. And we have a parallel process or a sequential process on in all those splits. It's a time consuming process because we have to first split the data, perform the scriptation, then we have to find the matches. Based on that, we have to the matches. Based on that, we have to write a query, and at the end we have to get all the data, and we have to get operation, and finally we have all the matches. So to reduce this complexity, what we have, we're just trying to reduce this grep part and matches part, and if we have to replace this part with map and reduce. So how the system is going to work over here now? Obviously, if you have very big amount of data, so you have to split the data, because we are working in a distributed file system environment, and there could be a different multiple system clusters, so we have to define the data into splits. And over here we have a process engine. Over here, this process engine is a map and reduce. So map has a whole sort of different activity, because in my the whole documentation, official documentation of Pig, I told you, if you have to perform this map activity under mapper class, so inside this class there is a code has been written over there. So first this code has to be executed. After execution of this code, we have some output. That output is going to send to this reducer class. Again, the reducer class is going to perform this code, and we have the output accordingly. Means, and simply we can see like this. Over here there is a map function and there is a reduce function, and this map function is governed by the mapper class, and whatever the code is going to be written over there, that will be the input of reducer class, and whatever the code written inside this reducer class, that will be the output, and that is going to have the final output over there. So we have to write this code accordingly. We are going to have the output. So why MapReduce? Because earlier what will happen if we have a problem, if you have had a problem with data, so what we have to say, like we have to transfer this data to the coder or to the solution architect who is going to debug this problem. But right now the data volume is going to increase exponentially. In that case, transferring this data to the system or the coder is quite difficult. So in that case, what we can do the reverse process. We have to just trying to migrate the code to the data, because the code size is not that much big as compared to the data. So here the orange box is basically a data blocks or SDFS block that is going to be towards the data or towards the code. So the blue box is a map task, or you can say code, and the orange box is basically a data block. So here the data block is going to migrate towards the code block. Means here the process is migrating towards the data. And the second good thing is why MapReduce is just the first step is we have to migrating code to the data, and the second step is each and everything is going to happen parallelly. Okay, means let's say we have a rack. What is rack? Rack is the collection of different systems. Let's say this is the rack having the collection of 10 computers. We can say this is cluster one. Okay, again we have the second cluster and the third cluster. So this is something will be termed as rack over there. Where as a whole we can say it's a data center. Now, what is the standard way? The standard way is each and everything, if you have data, so each and everything has to put inside SDFS, because SDF is our default file system over here. So we can export this data from MySQL. You can export the data from any web pages. You can use Scoop, Flume, anything over there as a data loading tool. you can load the data over here, like the data could be the CSV format, text format, any other format. Then you have to just put the data into HDFS. After this, on this data you have to perform some code. You can write your logics. The logic could be divided into two parts, the map logic and the reduce logic. And both is going to act parallelly, and after execution of this map logic and reduce logic, we have the output, and again the output is a data, and that output is again going to store into HDFS. So conclusion, whenever if we have data, be it the input data or be it the output data, it has to be into HDFS, first thing. Second, if we have to process, so we have to write a code. So this code could be in any language. It could be in Python, it could be in Java, it could be Pig, or it could be Hive. In simple, for Hadoop, this code will be termed as MapReduce process. No matter it's a Pig code, Java code, or any code over there. So first we have to run the map logic, and after this we have to run this reduce logic. Both have to be run parallelly. And after this we have output, and that output is going to store inside this our file system HDFS. This is the whole flow what we have to focus on that. Now this data could be into your local machine, this data could be into cluster, server, anywhere it could be happen like this. Okay, make sense? So for working over there, we have to understand the whole architecture of Hadoop, where someone is name node, someone is data node, someone is resource manager, what is the meaning of each and everything. We have to explain step by step, and at the end we have to go and have a demonstration for this. So let's explain each and everything over here. So over here, we all know this. The architecture of Hadoop is basically master slave architecture that's been discussed already in the very first class over here. So over here, like I say, whenever I'm going to use the word master and slave, so before this I have to watch what exactly Hadoop is going to do, what is the task of Hadoop. So over here Hadoop has only two tasks. The first task is it can deal with data, or we can say it can perform data storing like thing over here. And the second task the Hadoop can perform is like it can process data. Okay, so we have to write the second task is data processing. Whenever I'm going to see like this, we have to store data means you have the idea about data, data type, and you should have the idea about data format. Okay, and whenever I'm going to use the word processing, it means we have to write a code to getting the meaning out of data. Means you can write a code for this, and this code could be into Java, it could be into Apache Pig, it could be into Apache Hive as well. So whatever language you can know, you can write the code accordingly. So what exactly Hadoop say? Hadoop say, boss, you have to run your process, you have to just migrate your process to the code. Means the code is going to act on the data, or here I have to be very very specific, and the it should be input data. And after processing the code, we should have output, or we can say the result, and the result will be again output, we can say. So here I have to use the word output. So this is the output. So whenever I'm going to say the word data, so this data is going to deal with this data process or the data store, we can say like this. So who is going to take care of this data like task? So data has a two tasks. So you can say there are two daemons is going to act on this. So as there should be a master daemon, or we can say master process, and the second one is the slave for the very same activity. Okay, for data type of operation, the master process or master daemon of Hadoop is name node. In the very same fashion, for slave like activity, we have data node. Okay, moving further, if we have to perform the other activity like the second activity, so what is the second activity what we have in Hadoop? The second activity is data processing or writing a code, we can see. So in that case again we have master and slave. So in that case the master is the resource manager, and the slave for us over here is node manager. So whenever you are going to work in Hadoop, first thing you have to check is all these daemons are up and running or not. So for this, you have to go on terminal and type the command sudo jps, and this output should be name node, output should be data node, the resource manager, job history server, and finally the node manager and GPS should be up and running. So let's go on to terminal, check it out. My Hadoop is running or not. If any one is missing, let's say name node is not working, it means the data operation is not going to perform over there. Okay, so first go on terminal, check it out, the system is up and running or not. So let it be up. So what is the meaning of this? Each and everything is there. So there is a client. So let's say if you are for the system, we are a client who is submitting this job. Let's say we are going to write a code and going to see that this for a Hadoop ecosystem, try to run this code. So if you are going to assign any task, you will turn as client. Whosoever is going to perform the cluster level of resource management. Okay, so in that case, you will turn the resource manager. Node manager just goes a helping hand of resource manager. Is the node manager is going to take care of each and every node. Whenever I'm going to use the word node, means a computer. Job history server is something like going to maintain the information about the submitted job after the application master terminates the job, and we have the app master, we have container. So this we're going to discuss in the coming slides in details what is the meaning of each and everything. So in coming, so how to execute the map produce job. For this we have a write operation, means let's say you are a client, so what exactly you can do. First you have to go and ask to the resource manager, where is my job, where is my data node, where is my resource manager, is my RAM is active or not, we have space memory or not. And after this, we each and everything be acknowledged by the resource manager to the client. And after this is going to the confirmation from the resource manager is going to get the data from SDFS. Okay, and after getting the each and everything from the SDFS, when the next process starts, what is the next process? We whatever the code or whatever the job it has, it's going to submit the job to the resource manager. And after this, the resource manager has the task like it had to execute that whole job or code. So resource manager is going to looking for its ultimate subordinates, or we can say helping hand. So the for process activity, the helping hand of resource manager is node manager. So it's just going to assign the task to node manager. We have to go and start the container, start the app master. You can perform, look out which node is available for performing the data activity, and where we have to, after processing the whole task, where we have to store the data. So this sort of activity is taken care by the resource manager and non-manager, or simple we can see the whole sort of process activity is going to govern by the resource manager and non-manager. And at the end we have the output. Then output will going to store into SDFS, and that will be taken care by the name node and data node at the end. So for performing each and everything, first we have to go for the demonstration. The whole paradigm is going to explain. So the whole paradigm is going to explain in terms of code. So over here, where each and everything has to divide in the term like key and value. What is key? What is value? I will just going to explain each and everything step by step. So for this, let's. So before this, I have to go in my machine and check it out is Hadoop is working fine or not. So meanwhile, I'm just going to open my Eclipse to run the code in Java. And meanwhile, I'm just going to open my terminal, maximize it, and check it. Hadoop is working or not. So over here, go and type the command sudo gps, enter the password. So we have the daemon is up and running. For data, we have name node and we have data node. And for process, we have master daemon is resource manager and the save daemon is node manager. So each and everything is up and running, means we can perform our activity over here. So what is the activity? What we have to do? Let me rephrase it over here. So here we are here for understanding the concept of map reduce in general. So let's break both the term map and reduce. So what is the general meaning of that? For Hadoop, map reduce is a common terminology, but in general, for mathematics, you are coming for Java background. So for you, the map and reduce has both as identical word, both as a different meaning. So when we have data migration like activity, means we have to transport the data from one location to other location. In that case, that will be termed as map task in simple. But when we have data manipulation like thing, in that case, we can say that activity will be termed as reduced task. So what is the meaning of this? Again, let me explain in detail. Let's say you have a data. I'm going to write a data. Let's say e.txt file, and my agenda was there is something written into this. Let's say I'm going to say like this. In this data, something has been written. Hi, how are you? Again, something has been written over there. Hi, how are you? And your agenda was so you have to count how many times each and every word has been appeared. The first thing is like we have to write a code for this, and this code is going to act on this data e.txt, and after performing the activity we have the output, and that output could be in a file. Let's say the file name is part file. Okay, it has the output data. Okay, so how to do each and everything over here? So let's understand the whole process. So as I discussed earlier, whenever we have data, so this data activity will be termed as governed by name node and data node. And the first thing is this: the data could be anywhere. It could be like MySQL, it could be localhost, it could be into any server. And first thing we have to send like this: we have to send this data to HDFS. This is the first task we have to perform. And after this, when we have data into SDFS, the second task we have to write a code. Now this code is in, let's say example, we have code in Java. I'm just going to write the code in any of the IDE. It could be NetBeans, it could be Eclipse. Okay, let's say I'm going to use Eclipse over here. Okay, so you have to write the code in IDE, and then we have to export this code from this IDE. And I'm going to export the code of Java. It could be into a jar file format. Let's say it's a b.jar file. So this is the code. Again, what will be the flow? The flow could be the jar file code, or you can say simply the code is act on data. So for this, how to write like this? The code name is b.jar over here. This jar is going to act on data. What is our data? e.txt. And after performing this, we have the output in our HDFS again. Because why I'm saying the word HDFS? Whenever we have the word data, the data should be into our default file system HDFS. So over here, the input file a.txt and the output file. Let's say the output file is part file. Over here, both should be into HDFS. It could be the jar file is just exported from the IDE, so the jar file could be in your local machine. So let me rephrase again over here. This should be into your local machine. Make sense? The first thing, this is the whole flow how I have to write the code, and for writing the code we have to use the Hadoop environment and everything. So first thing we have to understand how to write the code, how to export the code for this. Let's go into the machine. Over here, let me zoom in and check it out. Is there any code or data or not? So let me check over there. I'm just going to create a file for you. Nano online one. I'm going to type something as a data. Okay, so I just trying to write something in my data randomly and just trying to save it. Okay, I just trying to show you the output over there of a data file using this. Right now this data is here and this is something into this, and I have to check where is the path of this online file, and for this I have to type the command pwd. So the home at Eureka and the file name is online1 is here. So my first agenda is, as discussed earlier, we have to, whenever we have data, so the data should be sent to HDFS. This is the very first task. So we have to go into terminal and trying to put the data into HDFS. So for this, with the command is HDFS dfs hyphen put. We have to type the whole path Okay, this is the whole data path which I try to copy from local machine to the HDFS or root directory of HDFS. That's why I'm mentioning the forward slash press enter. After this, I have to check it out. This data has been copied to the HDFS or not. For this, I have to type the command HDFS TFS-ls forward slash enter. It will go to list down whatever data we have in HDFS. So we have multiple data. So right now this data is online one. This is just going to copy it right now on the very same date. Now check it out. This we can have the output or not in HDFS. So for this we have to type cat and we have to mention the file name and press enter. So the same output what we have in local file system, the same output should be replicated over here. Is okay, totally fine. The first task has been done. The first task is we have data. Whenever we are going to use the word data, right now we are going to refer input data and try to copy this data into HDFS. So let me rephrase over here the steps so it could be easier for you. Step 1, copy the input data to HDFS, and for this you have to write the command HDFS TFS hyphen put the path of the input file, or you can say path of input data. Okay, then finally I have to mention the forward slash. The forward slash is going to indicate we are going to refer the root directory of HDFS. Now, what is the next step? Next step is we have to write the code to process this input data. Okay, so this code could be written into any language. So over here what we are doing, we are trying to write the code in Java. Okay, and for this I'm going to use my ID, and over here we are going to use Eclipse over here. Okay, so now we are moving for our next step, Eclipse. So I'm trying to minimize everything. I try to open my Eclipse, choose the workspace over there and say okay. Let it be loaded. So you can use any version of Eclipse over here. I am using Helios. So each and every one is going to work equally well. So let it be loaded. I think you all have a background of Java. So whosoever is working in the Java background, so they have to follow certain steps. Let me explain meanwhile it's loading. So working in Java code, what is doing there, you have to create a project. Inside the project we have to mention the project name. Then after this we have to mention the package name. Inside the package name you have to define the class. Okay, this is the whole flow how Java code is going to act over there. So we have project. Let's say I'm going to mention the project name as demo. Inside this you can mention the package name. Inside this we have to mention the class. Inside, after mentioning this class, we have to write the code. So this is the flow what we have to follow in Java or inside this IDE. Let's check now. We have some code is already written over there. This is the code I am going to use in future for WordCon program. Let's go step by step. First thing, you have to go to file. Over there we have new. Go on Java project. You can put mention any. Let's say I'm going to say demo. Say next, and we have to say finish. After having this, we at the left we have option SRC. Just go right click over there, and the next step is you have to click on package. You can mention anything over there. Let's say I'm going to mention the name edu. You can mention anything. Let's say be very specific. I'm going to mention e.b.c. Okay, and just press enter. After this package, what we have to do the next task? We have to create the class name. So our program is counting the words. So I'm going to mention word count and just say finish. So this is going to give me the workspace where I have to write my code. So by default, this is our package name is our project name demo. This is the package name e.b.c. That's why by default it's writing like this. And this is our class name or main class, or you can say the main Java code .java file we have, and we have to write the code. So the code is already with me. I'm just going to copy paste the code along with it over here. After copying and pasting the code over here, I'm just going to explain everything. So import means you're going to try to import the libraries or packages that is going to use over here. So the same thing has been explained in the documentation part over there. Let me go back and try to recall it. This is the code in front of you. You can follow the same steps. I tried to copy the whole code and trying to paste over there for the demo purpose. Okay, so there are dependent packages which are going to be used over here. Why are you going to import these packages? Because we are trying to write the code in Java. Okay, and this Java code is going to act along with Hadoop ecosystem. So what we have to do in Java code, we have to import the dependent packages of Hadoop into that. That's the only reason why we are trying to import the package of Hadoop into Java code. So make the system compatible with the Java code. Make sense? No. But whenever I'm going to import the packages, so just writing your import doesn't mean it's just going to do the task for you. Now, why this red dots are there? There's you see they are a problem. They are the warning. So what we have to do? We have to remove this warning. For this, we have to add the dependencies. For this, we have to just right click on the code, go to build path, configure build path, and whatever dependencies required we have to go and we have to add jar. For this we have to go to our file system. In Hadoop file system we have share folder. Inside share we have Hadoop folder. We have a multiple folder Hadoop MapReduce and common. So we have to go on two folders MapReduce and common. First I'm going inside MapReduce and whatever the jar files we have, we are trying to add the dependencies over here. So this, if you are a good coder, you have very much specific idea which jar file you can add. But I'm just trying to give you the basic idea that randomly I'm going to add each and everything. And let check order and export, select all, say OK. Now there should be some after adding these dependencies, some of the errors have been removed. Okay, but still there are multiple errors are persisting over here. So we have to add more jar file or more dependencies. So the same step we have to follow over here. We go to the libraries. Okay, add external jar. Now what I have to do, I have to go inside the common folder. Inside the con folder again we have multiple jar file. I'm trying to add those jar file again. Go in order and export section, select all, say OK, and after this whatever the error warning we have, that has been removed. So just removing the code doesn't mean the code is going to act, because this is the code which is in Java and in IDE. Okay, this code is what we have to do. We have to make this code work with this data. So we have to export this code from this IDE. For this, we have to just go click on export. Okay, by default it will look like this. This code in Java. Just click on Java. We have jar file. Say next. Where exactly you want to import this code. Let's say I want to import in desktop. You can mention any name. So I'm just going to mention this name is April 1. It's already there. So just say OK, next, and next. And after this data is going to store on your desktop named as April 1. So I have this jar file already. So I'm just not trying to do the same task. What you have to do, just mention the name, say next, and give the path. You have the data over there. So what is till now what we have performed? The next task is we write a code in Java and we are trying to export this code on our local machine, and in our local machine I store this file on .jar file. Okay, Java archive file. Now step 2 has been complete. What is the next task? Step 3 is now this jar file which has the solution, or we can see the code, is going to act on data, and this data is into HDFS with the name. Okay, what was the name? Online 1. And what is your jar file name? Is April. Okay, let's recheck it. What was the name of our jar file? It's april1.jar. So april1.jar. Now the jar file has to act on this data and give you the output, and the output should be into HDFS. Let's say write it like this. This output is going to store on any result named directory. Let's say I'm going to write like result new one. So inside this directory the result should be stored. Okay, so how to write the code for this? So for this code we have to go and type Hadoop jar Then I have to mention name of jar. Then I have to mention path of input data which are into HDFS. And then finally, what I have to do, I have to go over there and path of output directory. Again, it is in HDFS. Okay, this is how we have to write the code. Okay, so let's rephrase the code for you. Hadoop jar, our jar name is april1 dot jar. Our code name is online one. Okay, this is our data file name, which is in SDFS. And finally, we have to mention the output directory name. So it could be anything. Let's say new result one. This is how I have to write the code. I think this makes sense because inside I told you the process has to move to the data now. This is the concept what we have to follow in our slides. So now the process means the code is going to act on this data, and after this it's going to give us the output. This is the way we have to work on this. Why the Hadoop jar? Because we are going to work the whole thing in Hadoop. So we have to mention the Hadoop as a reference variable. If you're not going to use it, it's going to throw you error. So just move further for the practical part again. Now open the terminal. Let me zoom in and refresh each and everything. The first thing we have to go to desktop, press ls and check the jar file is there or not. So we have the jar file april1.jar. Now go into the HDFS and check it out. We have the data is there or not. The data name is online1 as input. We have the data online1 over here. Okay, and what is the output data name? This is new result 1. So it won't be there in HDFS, and real time it will be going to create over there. Now over there I have to type the command Hadoop. Let me just try to generate error for you. So what is the task is, first we have to mention the jar name. So april1 dot jar. Okay, this jar has to act on this data. We have to mention the data name online1, and finally data is going to store in the folder new result1 and press enter. It's going to say this, there is no any such command because jar means this file is going to work in Java environment. So nothing mentioned in front of this April file means this is the code for Linux. So for this we have to add a reference variable. So I want to perform each and everything into Hadoop environment, so that's why I'm mentioning Hadoop jar. Makes sense? So Hadoop jar, name of jar, then input file path and the output file path in HDFS and press enter. So after pressing enter, the whole process will start. So whenever I'm going to use the word process means resource manager come in a picture, and after this the whole map and reduce will start and we have the output. Just go and press enter and wait for this. We have to focus on each and everything over here. Resource manager has activated 8032. The token has been submitted and we have started our job. Whenever I'm going to start the job means a unique ID has been created, so it is in front of you, and after submitting this we have a process will start. So process means map reduce will start parallelly. The first map will start, map 0%, reduce 0%, and depending upon what sort of data size you have, what sort of code it will take time to finish the map task. So first the map task will finish 100%. After finishing of the map task, the reduce class is going to act and it is going to perform its operation, and the reduce class is going to finish. So right now the map task has been completed. Now wait for the reduce task to complete it, and the whole process is going to be wind up. Just wait. Now the reduce is completed. Now the whole task has been completed. Task completion means the data is going to store at our desired output location. So what was the location? New result 1. So just go into HDFS, check it out. SDFS hyphen ls forward slash enter, and we have to figure out that particular directory name we have the data or not. What was the directory name? Result new result one. So we have to figure out this data is there or not. Okay, so we have this folder over here, new result one. So this is basically a directory. So we have to go and do ls new result one to check it out what exactly into this. Now into this we have two files, the success file and part file. The success file is having the size of 0 byte, so this is a notification file, and the next file is having a 71 bits, and this file name is part file. Okay, so the Hadoop system by default going to generate this file, so we have to go and do the cat operation over there. So getting the output from any file, we have to write cat, and after this we have to mention the file name part hyphen r hyphen 5 times 0 and press enter. So whatever the data as input data we have, it's just going to process and give the output. It's counting the words how many times each and everything is going to appear. So what was the input we have? This is the input file online world. In this, hi, how are you? Hi, how are you? Something has been mentioned over there. So how many times hi appear? How many times how appear? How many times R appear? How many times the Microsoft has been appeared? Each and everything should be counted and give you the output. Let's check the output. So only one time Microsoft, one time Anand, and whatever has appeared to a four time it is going to be counted and give you the output. So no matters how big your data is, the data could be of 1 GB or 1 terabyte, the process will remain same. Okay, the code will remain same. What will vary? The only variation will be the time of processing this data. This is how this whole map of this paradigm is going to act over here. Now, some you may ask like this in the slide over here, why we have to explain the anatomy of MapReduce program. So in the MapReduce program, it will going to split in two parts, map part and reduce part. So what is map and what is reduce? Just go on the code again. This is the name of our main class name. Inside this, we have two type of class. The first class is map class. Now what map class is doing is extending the property of mapper of Hadoop, which have already been imported over here. Okay, and what is say the map class C can read the data if I have data in such a format, long writable, text and writable. So initial two one is the input type and the next is the output type format over there. So we have to convert this data into long writable text and in writable format, then only we can understand. So what is the meaning of this? Let me go to the slide again. So what map say? It has two input or two output. Whatever it has in map, that should be into key and value format. So what is key? Anything which is unique is a key. Anything in general could be a value. Let's say Anand. Anand, there could be a different person having the same name Anand, but I have my mobile number which is unique with me. So in that case, my mobile number is a key and my name is a value. So I have to pass the value accordingly. I have to convert the data, whatever data I'm getting. Let's say this is the data, the green box, deer, beer, river, this is the data. So first I have to split this data into different records, and for each and every record I have to generate this key1 and v1, means this first red box has a key and value. So what I have to do for this r1, r2 or r3, record 1, record 2, record 3, I have to generate key1 v1 for record 1, k2 v2 and k3 v3. So who will decide what is the meaning of key, what will be the value of is there. So for defining key, so depending upon the file input format, if this input file format is a text type, in that case the key will be byte offset. Byte offset is the first bit of any record or any line. So over here the first bit is 0. The index value is over here is 0. The key, what is key? K1 is over here is the value of K1 is 0. And what is the value? For if the data is a text type, the entire line will be termed as value. So deer, beer, river will be termed as v1 over here. Okay, makes sense. In the very same fashion, for record number 2, what is the meaning of k2 and v2? So for finding out what is the meaning of k2 over here, just go to the second line, car, and river, and count number of bits before this for C. So we have deer 4 bits, beer 4 bits, river 5 bits. So Altogether we have 13 bits, 2 spaces, 14 and 15, one new line 16. Means the total value of byte offset for the second record is 16. So what is the meaning of the key2? The key2 is having of 16 bit. Byte offset is 16. And what is the value? V2? V2 will be the entire line. Car, and they will be termed as the entire line will be termed as the value. So what is the type of key1? The key1 is of int type or long type. So how we write in Java or in Hadoop, we have applied a long writable or in-writable. So what is value? Value is of a string type. So we have to typecast it as a text type. Just go to the code and check the same thing for this. Let me clear the screen first so that you have the clear idea. So in this machine, just let me open the code. So we have input key1, which is long writable, like it could be a 1, 16, 18, 20 bit, depending on data, it could be a huge number. That's why long writable. The value could be of string type, so text. Again, we have text or int writable. So how the value will go to decide? So this output will depend upon how this code is going to act on this data. What we say, whenever you have the value means the text, just convert this text into string using the toString function, and whatever the data we're generating, just assign 1 after this. Means what is going to see like this? See like this, boss. The string is hi, how are you? First, you have to generate key1 and v1 in this case. The first record, just go to the first character hi. What is the number of character before this hi? That will be byte offset. There is nothing before the word or the letter h. So here the key1 will be termed as what? 0. And what is the value? Value is entire line. So value will be hi, how are you? Makes sense? It means this is the meaning of our key1 and v1. Now come to the second record. Let's say I am fine over here. So in that case, what we have to figure out here, we have to figure out the K2 and V2. Again, the concept will remain same. What is K2? The byte offset value, and just go to the first character on record 2 and count whatever the record value before this. Means we have 2 character, 3 character, R and U. So all together we have how many characters we have? 2, 3, 5, 6, 7 spaces. Count the spaces 8, 9, 10. New line. We have total altogether 11. New line, spaces, each and everything is a key value. Means this is whenever I'm going to press any key on laptop, it has a mask key value. So yes, it is the value is 11. And what is the V2? V2 is byte offset, means entire line. Makes sense? So now we have to typecast it. If this data is too huge, in that case it will be of long type. Data is of, you can say, a small size, we have to typecast as int. So in Hadoop it will be like long writable. If it's of int type, is int writable. This is how we have to write data into Hadoop. And there's no concept of string in Hadoop. So whatever data which is unstructured, that will be termed as text. So K1 is of something like long, and here is like V1 is a text type. Now whatever data we have to, the code is going to act on this input data and going to give you the output. Now what will be the meaning of output? Just one code. Now what we're going to say is, whenever you have value, just go collect this value and convert into strings. So what is value over there? So value is hi, how are you? I am fine. So what I'm going to do, I have value hi, how are you? What the code say? Code say you have to convert this using the toString function of Java. You have to convert the whole value into different words like hi, how, are. Let me go at the bottom. Okay. So using the code, I'm just trying to convert the whole statement into different word. I'm just going to tokenize it, as simple as that. Now, what the code say again, after tokenizing the code or making this toString function, just whatever new token we are getting to have, and just assign the value 1 as per the code. So I'm just going and assigning the value 1 to each and every tokens as per the code. Just go to the slide and check it out. This is the mapping phase. Means in red there is a record. In mapping phase we're just trying to map one to the records over there, the list over there. And after this we are going to sorting and shuffling. Means if you have the same words repeated, you have to write like this. So over here, let's say I'm going to have the second word. I have again hi, how are you has been written over there. So what will be happen? It is just going to act like this. It means that will be termed as key 1, that will be termed as v1. But if we have a duplicate record, let's say I have this record comes again and again. So what is the meaning of like the word key? Because key should be unique. Here hi appears 2 times. There is no any concept of uniqueness. So in that case, what Hadoop say, instead of this, just try to write like this to provide a uniqueness. How many types it appear? Okay, the same meaning, but what happened over here? The each and everything has been customized like this. So over here, the concept will remain same because mappers say whatever the data we are getting, try to store the data into key 1 and v1 or key and value format. So now, what is the format of output? Text, and v1 means it's of int type, so type int writable. Makes sense? So this will be the output of mapper. And here, this is the input of your map. Hi zero, how are you? So long writable is the input type, and here text comma int writable is the output type. Just go to the code and check it out. So in mapper class, public class map extent mapper, initial to one is the your input type, and next is your output type of your mapper class. Makes sense? The same thing has to mention the slide over here. Yes, beer, car. Now, till now, over the blue box, the map phase has been complete. Now we have to go for the reduce phase. What reduce say? Just go to the code and go to the reduce code. What reduce say? Whatever the data we are going to have, just try to sum it. Means the data we are collecting, just try to collect the values. Okay, what is the value over here till now? Here the value is 1 1 because this is the mapping phase, this is the key, and this is the value. And values of int type. So map say just collect the value and try to sum it. I'm just going to perform the sum operation on the values. So sum, we have to sum the value. Okay, so just go on notepad. What is the value over there? 1 and 1. So how many times 1 appear? 2 times. What I have to perform? I have to perform this. So how the value and how the output will look like? Just go and check it out. So it should look like hi, comma 2. This is the output, and the same output we are getting over. Let me go check over here. This is the same output we are getting over here. Make sense? So this is the whole paradigm, how exactly the map reduce paradigm works, what is the meaning of key and value over there. So in simple we can say the whole map reduce paradigm, the mapper class, the reducer class, each and every one is going to work on key and value, and whatever the code has been mentioned into that, depending upon that code, key1 v1 k2 v2 is going to operate. So in simple we can see the map reduce engine, the process engine of Hadoop is going to work in key and value, and this key and value will decide upon depending upon the input data type. So what is the meaning of input data type and output data type? Just go on a code. So on over here at the bottom of the particular package importing, we have file input type, okay, and file output format. So what is the format over there? That is text. So whenever you have data type of text type, okay, input data is text type, in that case the key will be of byte offset. I told you earlier, whenever you have that case, you have the byte offset will be your key, and the entire line will be your value. Okay, if you have sequential file, the definition will change. If this is a binary file, the definition will change again and again. I think this sounds clear. It's okay for everyone. So this is a demo workout program. We just trying to finish the demo workout program. So till now, the whole concept of MapReduce, what is MapReduce, what is the master and slave architecture, who will master, who will slave, how to add the dependencies, and in YAR we have to focus on high, we have to focus on pig, how pig is going to work, and how Java is going to work along with Pig using UDF. Each and everything will be going to discuss in the coming classes. Thank you, class. We are going to wind up the class for the MapReduce and the Hadoop architecture. Thank you.